Welcome, friends. I'm so glad you're here. Whether you're drifting towards sleep, unwinding after a long day, or simply looking for a quiet companion, you've found the right place. Perhaps you're resting under a soft blanket or seated by a window where the night sky hums faintly beyond the glass. Wherever you are, I hope you're warm, comfortable and ready to wander with me into the oldest question we have, not where the universe begins, but whether it ever truly does. If you find peace or curiosity in these gentle stories, please consider sharing them, or simply stay and listen as we fall backward through time together. The universe is supposed to be 13.8 billion years old. That number so specific feels like a cornerstone. It comes from matching the faint cosmic background glow to equations that describe expansion, a fit between theory and the oldest light. Yet beneath that calm surface lie tiny tremors, irregularities, outliers, clues that the beginning might not have been so cleanly drawn. The background radiation itself, the microwave afterglow of the Big Bang, carries within it ripples of temperature and density, each a fossil from the infant cosmos. These patterns tell astronomers how quickly the universe expanded and cooled, how long the first atoms waited before light could move freely. But here is the first soft irony to read the beginning. We rely on the universe's memory of itself, and memory even cosmic blurs at the edges. Another irony hides in the precision of the number. The equations that give us 13.8 billion years assume that the universe has behaved uniformly, that its rate of expansion has been smooth, that nothing unseen interfered in the quiet of its early days. But evidence from multiple corners, ancient stars, distant galaxies, even the faint rhythm of the background itself begins to strain that frame. It would take only a small shift, a slow early pulse for the true age to lengthen. Perhaps not infinite, but older than comfort allows. Only took a few more decimal places to move the beginning beyond the beginning. Scientists listen to the background like archaeologists brushing dust from stone. The light is everywhere the same, in all directions, cool to a few degrees above absolute zero. It hums in microwaves invisible to eyes, but audible to instruments, a soft static that television screens once translated as snow. Within that glow are the seeds of everything, small overdensities that became galaxies' voids, that became cosmic emptiness, and ratios of hydrogen and helium that still define chemistry today. And yet between the ripples there are anomalies, regions smoother than expected, colder than predicted. The cold spot in the southern sky, vast and inexplicable, lingers as a bruise on the model's otherwise perfect skin. It could be a statistical fluke, a cosmic coincidence, or evidence that something else brushed against our universe before it fully inflated. The poetic detail here is that these irregularities, too faint to notice by eye, represent a possible trace of something older than the Big Bang's clean story. A prelude not erased, just muffled. There is a quiet scientific mystery in the way this glow fits time. If the cosmic background truly marks the end of the opaque era, when photons decoupled from matter, then all older information lies trapped beyond it, unreachable by light. But there are whispers of other messengers, gravitational waves from before the glow, the tremors of space-time itself. Detectors built to feel these vibrations wait in silence, their mirrors so still that passing trucks on nearby roads mimic creation's earliest murmurs. So far, nothing certain. The irony again, the closer we listen for the beginning, the further it retreats. Time like light redshifts into abstraction. The first atoms formed, the first light escaped, and yet the boundary keeps blurring like frost melting as one reaches to touch it. Only took a universe expanding at the speed of comprehension to make certainty outrun us. He the voice observes that our measurements of age depend on a constant called the Hubble parameter, the number that ties velocity to distance. Measure it one way using the afterglow and the age comes out long. Measure it another using nearby supernovae and galaxies and the age shortens. The two clocks disagree by enough to matter an argument between early and late light. If the older clock is right, the universe might be younger. If the younger clock is wrong, it could be older. The paradox is symmetrical and unresolved. A universe that cannot agree on its own tempo may not be the same universe throughout its life. A final irony lingers at the threshold of this first section. For all our equations and telescopes, we still define the beginning through light, and light, however fast, is memory, not presence. What we call the origin is already a reflection, a pale remainder. The cosmos we see is not the cosmos as it was, but as it looked billions of years after it began. The whisper before the beginning might still be speaking too low for our detectors to hear. The night outside your window, calm, quiet, cool, contains radiation from the earliest fire photons that have travelled the entire history of space to reach your eyes. Their journey may have started longer ago than our clocks admit. Only took a few more billion years to make eternity seem local. He holds the clock in both hands and feels how softly it ticks, because in cosmology time is measured not by gears but by stretching space. And the accepted fact is simple enough to rest on the Hubble constant links, distance and recession speed, so that farther galaxies recede faster, and by integrating that expansion one recovers an age for the universe. The number is not an ornament, but the dial itself. He lets methods assemble like nested rings around a quiet lake. One ring begins nearby with the distance ladder parallaxes in the Milky Way set the first rungs. Those rungs calibrate standard candles, Cepheid variables whose periods tell their luminosities, and the tip of the red giant branch where old stars ignite helium with a nearly fixed brightness. Those calibrated beacons then anchor the true powerhouses, Type Ia supernovae, in distant galaxies, whose standardized light curves trace the expansion of space over hundreds of millions of parsecs, fit a smooth relation between distance and redshift, and the Hubble constant emerges for the late universe. Another ring begins far away and long ago in the fine-grained pattern of the cosmic microwave background. The positions and heights of its acoustic peaks encode the sound horizon of the primordial plasma, and when paired with a cosmological model, they imply a value of the Hubble constant for the entire history, as read through early light. A third ring lies between baryon acoustic oscillations, the fossilized ripple scale imprinted in the distribution of galaxies, a standard ruler that, when combined with supernova distances or with the background, triangulates the expansion. A fourth ring edges the method set with time delay strong lensing, where a foreground galaxy bends a background quasar into multiple images whose flickering arrives with delays set by both geometry and the expansion rate. Time, light, mass and curvature weave a single number out of many paths. A lesser-known detail makes the ladder feel sturdier in the hands. Water mazes in the circumnuclear disk of NGC 4258 trace Keplerian rotation with pinpoint radio interferometry, giving a geometric distance independent of candles. That distance calibrates Cepheids observed in the same galaxy, which in turn calibrates supernovae, an external brace for the nearest rung. Equally quiet is the tip of the red giant branch technique, less sensitive to dust and metallicity than Cepheids, and therefore a check on the ladder's colour and grain. He places a quiet scientific mystery in the clockwork because the rings do not agree. The Hubble constant inferred from the early universe via the background and standard cosmology is lower than the value derived from the late universe via the ladder and supernovae by an amount too large for comfort and too persistent for simple error. Add time delay lenses and some cosmic chronometer methods that estimate expansion from the differential ages of passively evolving galaxies, and the pattern remains multiple late-time approaches cluster higher than the early universe inference. If the early value is right, and the model complete, the universe is older for a given present-day expansion. If the late value is right, the universe is younger under the same model, or the model itself bends. He lays three soft ironies in a neat line. First, the parameter called a constant drifts between methods, so constancy becomes a property of models, not of measurement. A constant that is not constant feels like a poem hiding in an equation. Second, to measure the present expansion, we mostly stare into the past, supernova billions of light years away. So now is recovered through then, and the more precisely we observe the distant, the more sharply we argue about the immediate. Third, microscopic calibration shifts in nearby stars, fractions of a millisecond in parallax 0 points, a few percent in metallicity corrections, a small rethink of dust propagate into gigaparsecs and giga-years. Only took a nudge on the first rung to tilt the whole ladder's horizon. He keeps the science slow even. On the background side, the sound horizon at recombination is read from the spacing of peaks in the microwave spectrum. Given the densities of baryons and dark matter, the physics of the photon-baryon fluid sets that scale with high confidence. Translate the angular size of the sound horizon into a distance. Assume a flat universe with cold dark matter and a cosmological constant, and the Hubble constant follows as one component in a fit that explains not just the peaks, but their heights, the damping tail and polarization patterns. The early universe inference is global model dependent and astonishingly precise. On the ladder side, the story is local empirical and layered parallax from space delivers distances to nearby Cepheids with microarc-second precision. Those Cepheids calibrate ones in host galaxies of type ER supernovae. The supernovae then map a smooth Hubble flow. The TRGB path runs in parallel cross-checking distances in the same hosts. Masers and eclipsing binaries provide geometric anchors. Dust extinction laws are measured, not assumed. Each correction carries its own error bar, and the agreement among independent rungs matters as much as the final number. Between these poles, the lensing delays act like the steady beat of a metronome. Measure the time differences between images, model the lens mass with stellar kinematics and high-resolution imaging, marginalize over external convergence from line-of-sight structure, and expansion turns delay into distance. Different lenses, different teams, similar answers, late time high side. He folds in a second quieter irony. The most straightforward ruler the sound horizon lives in a plasma no one can touch, while the most empirical rung Cepheids and red giant tips depend on stellar atmospheres whose subtleties defy simple models. Theory gives a clean ruler in a messy epoch, observation gives a messy ruler in a clean approach. Both are necessary, both are faithful, and fidelity to both yields discord. He lets small names carry large roles. SHE-OS, a nearby ladder program, tunes Cepheid 0 points with parallaxes and messes, and lands on a higher Hubble constant. TRGB-based routes land slightly lower, but remain above the background value. HGO-LICO and its successor collaborations stack time delay lenses toward the high. Other methods surface, brightness fluctuations, tip calibrations in halos with minimal dust. Megamassa distances keep the ledger wide but convergent at late times. The early time pillar drawn from Planck's background maps under the standard model stays low and stubborn. Baryon acoustic oscillations comfortably bridge background and low redshift expansion when partnered with supernovae favouring the early universe value under LCDM. The tension stands not as a crack but as a seam. He places three more ironies to keep cadence. Only took a parameter measured to parts per 100 to reopen questions that seemed closed. Precision destabilizes certainty. Only took agreement across many late-time techniques to make disagreement with one early-time inference feel bolder rather than weaker. Consensus breeds conflict when it gathers on both shores. Only took a constant written in kilometers per second per megaparsec to decide whether the universe today is older by hundreds of millions of years, or younger by the same units that sound small, deciding ages that sound large. He admits the possibilities without choosing drama. Perhaps unknown systematics still hide in one or many ladders crowding in Cepheid fields, dust law variations, metallicity trends, selection effects in supernova hosts. Perhaps lens models understate mass sheet degeneracies, even after kinematic checks. Perhaps the sound horizon is mismeasured not by observation but by physics. Additional relativistic species in the early plasma, early dark energy, that briefly raised the expansion rate and shrank the ruler-mild interactions in the dark sector. Each hypothesis leaves fingerprints in other data. Nuclear synthesis yields structure, growth rates, polarization patterns, the shape of the baryon acoustic feature, and those cross-checks have not yet crowned a culprit. The quiet scientific mystery is not merely which value is correct, but whether value belongs in the singular. He lets a gentle analogy rest on the mantle. The cosmic clock resembles a clock with two pendulums mounted on the same case. One swings with a period set by the early hot interior, the other by the current cool room. In principle, the case ensures harmony in practice. The pendulums tick slightly out of phase. An observer hears a beat that wavers, then steadies, then wavers again. Fix the case. Adjust a pendulum or accept that both belong, and the clock is more complicated than the first glance allowed. He returns to age because the project asks whether the universe might be older than we imagined. He does not push beyond consensus, but he notices that if the early universe inference holds, the age remains near 13 billion years. If the late universe measurements reflect reality within LCDM, the age shortens. To make the universe older, one entertains changes to the model that slow early expansion, or stretch the integral of time without breaking other fits ideas that sit under active, careful scrutiny. Only took a small adjustment in the equation of state of dark energy at very early times, or a mild change in relativistic degrees of freedom, to move the clock by amounts larger than a casual ear would notice. Only took a different curve, not a different story. He ends this clockwork as he began, with restraint and with the ledger complete, one accepted fact. The Hubble constant turns redshift into expansion, and expansion into age. One poetic lesser-known detail, geometric water masses in a single galaxy, NGC 4258, anchor an entire ladder of brightness across cosmic distance. One quiet scientific mystery, the persistent Hubble tension between early and late universe determinations, and whether it signals unknown systematics or new physics that changes the expansion history. Three soft ironies, the constant that is not constant across methods, the present measured by staring at the past, and tiny local calibrations deciding the age of everything. The clock keeps time whether or not our labels agree, and he lets it tick weightless, exact and slightly out of phase, while the wider story drifts forward with the patience of light. He lets the gaze settle on single points, because sometimes an argument about the universe's age begins with one quiet star. Accepted fact is a soft anchor. Here, the oldest stellar populations in the Milky Way ancient halo subgiants and globular clusters form soon after the first atoms and mark timescales near the birth of galaxies themselves, their ages clustering around 12 to 13.5 billion years when distances and physics are set correctly. A pale subgiant in Ophiuchus, once nicknamed the Methuselah star, becomes a case study. Its spectrum shows extreme poverty in heavy elements, and a surface chemistry marked by oxygen and iron in ratios that speak of the earlier supernovae. When its distance is nailed by precise parallax and its brightness corrected for interstellar dust, stellar models place it at an age that once seemed to exceed the universe's around 14.5 billion years under earlier inputs, but revisions to opacities, reaction rates, and especially distance bring the estimate downward into comfortable consonance with the background's 13.8 billion year clock. The star does not embarrass the cosmos, it calibrates it. A lesser-known detail glows in the way that age is read. Subgiants like this one live in a narrow region of the Hertzsprung-Russell diagram, where luminosity changes quickly with time, so a small shift in distance or chemistry bends their ages by hundreds of millions of years. Even the Sun's carbon-nitrogen-oxygen cycle rates, measured in part by solar neutrinos, feed back into the models that set how fast similar stars evolve. Thus, the age of a halo star hinges on reactions taking place in the quiet heart of another star entirely. The ledger is local and global at once. He keeps a quiet, scientific mystery beside the subgiant because uncertainties remain honest. Surface abundances change as deep mixing dredges products of internal fusion upward, and diffusion can let heavy elements sink below a star's visible photosphere over giga-years, leaving spectra that are slightly misleading unless corrected. Convection, rotation, and magnetic fields alter temperature gradients that models approximate. And parallax 0 points, though exquisitely small, still nudge ages. When all allowances are made, the oldest single-star ages settle shy of or just at the universe's age as they should, but the corridor is narrow enough that small future corrections could widen or narrow comfort without changing the story. He walks outward from single stars to whole swarms because clusters average noise into signal. The accepted fact holds globular clusters. Dense spherical swarms orbiting the Milky Way are among the oldest bound systems known, with ages typically around 13.5 billion years. Their colour magnitude diagrams draw clean turn-offs where hydrogen fusion begins to fail in the core, and the turn-off's position sets an age mostly independent of distance, once distance moduli are tied by standard candles in the same cluster. White dwarf cooling sequences provide an independent clock. The faint end of the white dwarf luminosity function acts as a pile-up where cooling slows, and its location heads the same way deep antiquity. Clusters like M92 and M15 sit at the high end of these scales, while others show multiple populations that reveal early brief episodes of enrichment. Each cluster is a small fossil, and together they form a ridgeline near the dawn of galaxies. 3 soft ironies arrange themselves beside this ridge. First, the stars that challenge the universe's age are not the bright celebrities, but the modest subgiants whose glamour lies in a slope on a diagram. Humility carries the larger argument. Second, the best clocks for old ages are the faintest embers, white dwarfs cooling almost into invisibility, so the dimmest objects decide how long everything's been shining. Third, the problem stars that once seemed older than the universe survived not by breaking physics, but by improving it better. Distances, better opacities, better nuclear rates, so anomaly becomes a lantern for refinement rather than a verdict against the frame. He brings spectroscopy forward because chemistry is a calendar. Some halo stars contain trace amounts of radioactive thorium and uranium. They are process byproducts of ancient neutron star mergers or rare supernovae. By comparing present-day abundances of these nuclei to stable R-process elements, such as europium or osmium, and knowing the half-lives of thorium-232 and uranium-238, astronomers read a cosmochronometer. The resulting ages carry large bars order of giga-year uncertainties, but often land near 13 to 14 billion years, a pleasing independent echo of cluster and subgiant results. The method's lesser-known detail is that the initial production ratios how much thorium to europium was made in the original event must be inferred from nuclear models and from the yields of a handful of bright R process-enhanced stars. The clock's tick depends on a chemistry lab we cannot yet run to completion. He sets 3 more soft ironies beneath the spectrograph. Only took the rarest elements in the oldest star's traces of heavy nuclei at parts per trillion to argue with the age of everything. Only took decay times longer than the span of civilization to make a measurement we can write down today. Only took a catastrophe far away and long ago a neutron-star merger to leave a residue that behaves like a gentle metronome in a quiet halo star. He turns to the white dwarfs themselves because their cooling is slow enough to watch with statistics. The faintest white dwarfs in a cluster set a floor to star formation. They're stars that would have had time to evolve. To white dwarfs will be present unless the cluster began later. By modelling the physics of crystallization in white dwarf cores and the release of latent heat, astronomers have refined those cooling ages until they agree with main sequence turn-off ages within uncertainties. The harmony's not trivial. It is an independent physics experiment electron degeneracy. Coulomb plasma's phase transitions yielding the same timelines as stellar fusion models. A lesser-known detail flickers here when white dwarf interiors begin to crystallize their cooling slows, temporarily producing a pile-up in the luminosity function, a visible echo of a phase change occurring in a star the size of Earth. Time leaves fingerprints at the bottom of the temperature scale. He lets kinematics provide another check because motion remembers order. The oldest populations in the Milky Way, the inner halo and the thick disk, carry distinctive velocity ellipsoids and angular momentum distributions. Their stars exhibit low metallicities and enhanced alpha elements, consistent with rapid, early enrichment dominated by core collapse supernova. These signatures mapped across the sky point to merger events early in the galaxy's history that heated orbits and assembled the halo. Ages drawn from turn-offs, white dwarf cooling, and nuclear cosmochronology for these groups converge on timelines that begin within the first billion years after recombination. The galaxy's stones align with the universe's pavement. A gentle modern analogy keeps the pace level reading stellar ages across the galaxy resembles standing in an old library, and dating the building not from a single cornerstone but from many quiet clues. The style of the brick, the wear on the stair treads the paper of the oldest books, the patina on the railings. Each clue carries its own uncertainty and its own physics. Together they make a date that feels less like a number and more like a season. He returns to the headline that tempts an older universe and keeps the language careful. Individual stars once appeared to exceed the cosmic age because one or more ingredients were off by small amounts, distance reddening opacities or nuclear rates. With better parallaxes and refined stellar models, those stars now sit at or just below the cosmological age. Globular clusters similarly have not broken the bound. The possibility that the universe might be older does not rest securely on stellar archaeology as of now, and yet the closeness of the match ages within a few percent of the global value remains a whisper worth hearing. Formation of long-lived stars begins very early. Galaxies assemble quickly enough to populate halos with ancient members whose clocks nearly equal the cosmos's. In that sense, the universe feels old almost immediately after it becomes transparent enough to see. He keeps uncertainty visible where it belongs. Diffusion corrections in stellar atmospheres may be incomplete. Mixtures of helium in cluster stars could shift turn-offs faintly. Three-dimensional hydrodynamic effects and non-LTE line formation complicate spectroscopic abundance scales. Nuclear reaction rates, especially for the proton-proton chain and CNO cycle, carry residual error bars. The initial thorium to europium ratio in our process events remains model-dependent. Each caveat is a low-voiced reminder that precision is a process. None presently require more age than the background allows. He adds a final trio of ironies to keep cadence. The very stars that make the case for great antiquity are also proof that time is generous to small lights. They live because they are unremarkable. The cosmic timeline is confirmed by objects that have done almost nothing for 13 billion years, except fuse quietly idleness becomes evidence. And the closer our measurements bring stellar ages to the universe's age, the less room we leave for being wrong, and the more magnificent it is that agreement persists. Precision threatens comfort and rewards it in the same breath. One accepted fact rests at the centre. The oldest halo subgents, globular clusters and white dwarf sequences point to formation epochs within the first billion years, and ages near 13 billion years, consistent with a 13.8 billion year universe. One poetic, lesser-known detail glows at the edge: radioactive clocks that tick in thorium and uranium abundances, tiny traces acting as calendars longer than galaxies. One quiet scientific mystery remains: how fully we understand the physics that creeps into stellar ages through diffusion, convection, and nuclear rates, and how narrow the corridor between stellar and cosmological ages can honestly be. Only took a better distance to make a star younger, only took a faint crystallization bump to make a cluster older, only took the decay of a nucleus no eye can see to keep our clocks aligned with the largest number we know. He leaves the ancient points where they already are, pale, patient, and nearly as old as the light that made them visible. He slows the frame until expansion becomes a breath rather than a race, and in that gentle pace a single accepted fact holds the room steady. The universe decelerates when matter dominates and accelerates when dark energy dominates. So the cosmic history carries a transition long ago. Gravity wins and slows the flow. Later, a smooth pressure with negative sign takes over and speeds the stretching. The equations that describe this, the Friedmann relations tie the scale factor's second derivative to the energy contents and observations, place the handover at a redshift near 1/2, when the universe is only a few billion years younger than now. Before that structure grows against drag. After that, separations widen under a quiet push. He lets tools that feel slowness take their places like faint buoys on a slow tide. Typea supernovae traced the luminosity-distance redshift relation and revealed the late-time acceleration, first faint candles marking a curve that bends away from simple deceleration. Baryon acoustic oscillations imprint a standard ruler. The sound horizon from the early plasma and the angular and radial sizes of that ruler at different redshifts turn slowness into numbers. The cosmic microwave background encodes the early cadence in the pattern of acoustic peaks fixing a starting tempo. Galaxy, clustering and weak gravitational lensing measure growth the way lumpiness rises under gravity against expansion. Taken together, they describe a slow beat that changes sign a youth that breaks a maturity that glides. A lesser-known detail lives in the middle distance where patience becomes method. Cosmic chronometers read the differential ages of passively evolving galaxies at nearby redshifts to estimate the Hubble parameter directly Hz. 1 plus 1 dz dt. Small differences in stellar populations' ages across small differences in redshift provide a rate without ladders or rulers. The approach is quiet, model-aware, and fragile stellar population synthesis and metallicity drift can nudge the dial. But when many chronometers agree, the slowness finds a local value that checks both lights and rulers. Another subtle meter waits still more patiently. The Sandage Lobe redshift drift a direct measure of cosmic acceleration as tiny changes in spectral lines over decades, centimeters per second per year, a slow music most instruments cannot yet hear. Observatories plan to listen anyway, because a tempo measured by watching a single note slide will feel like weather, not memory. He keeps a quiet scientific mystery at the heart of the beat because the slowness that weaves data together frays at its ends. The Hubble tension remains early universe inferences from the background, and BOO favour a lower H0 late universe ladders and lenses favour a higher one and a sibling. The growth tension whispers that structure seems to grow slightly more slowly than some models tuned to the background predict a small shortfall in S8, the lensing amplitude parameter. The two tensions might be unrelated systematics divided by method, or they might be shadows of a single adjustment to the early script, an episode of early dark energy that briefly lifts the expansion near recombination and shrinks the sound horizon, or a mild dark sector interaction that alters growth. Each fix must preserve nucleosynthesis, the background's higher order peaks, and large-scale structure statistics. None has yet been crowned by convergent evidence. The beat remains beautiful and slightly off. Three soft ironies settle along the stave. First, a phenomenon named with a single constant Hubble's turns out to be a function of time hz, so constancy becomes an index rather than a property, a constant that instructs us to measure how it changes. Second, acceleration makes the universe older. In one sense, more time stretches between fixed redshifts, and emptier, in another fewer new structures form, so the same push that lengthens the calendar thins the content. Longevity trades against growth. Third, the curve that reveals the slow beat, a relation between brightness and redshift, is drawn by supernovae that live and die in a flash compared to cosmological time. Short-lived sketch long ages. He peels back to first minutes only to carry the beat forward, Big Bang nuclear synthesis operating when the universe is seconds to minutes. Old sets, light element abundances that agree with measurements in pristine gas clouds. Deuterium's exquisite sensitivity to the baryon fraction acts as a cross-check on densities used to fix the background. That early constraint fixes the pressure that the later beat must integrate. Any proposal to change the sound horizon with early dark energy or extra relativistic species must dodge the anchors set by helium and deuterium. The rulers do not float freely. The river's source fixes the downstream volume. He lets geometry share the page with growth because the beat is two-handed. Distances diagnose the expansion history, while clustering and lensing diagnose how gravity fights that expansion. Weak lensing maps from wide-field surveys trace a web whose statistical amplitude and scale dependence encode both matter, content, and growth rate. Redshift space distortions, squashing and stretching of clustering along the line of sight measure the peculiar velocity field, another barometer of growth. Together they say how sticky gravity is as the metric stretches. A gentle irony repeats itself, where distance measures often prefer a slightly higher acceleration. Growth measures sometimes prefer a slightly stronger break than the simplest model would suggest. The metronome's left and right hands drift by a beat. He threads in distances that live between the very near and the very far because mid-tempo matters. The Limone forest at redshifts 2 to 3 provides BAO measurements in absorption along sight lines to quasars extending the ruler into an epoch when matter still dominated. These high redshift Bayer points bridge the background's forecast to the supernova's report knitting a long arc. Time delay lenses with their delays measured in days to weeks, and their geometry set by megaparsec scale potentials place single elegant markers near redshift 1. Surface brightness fluctuation distances add a local cross-check to ladder rungs that would otherwise depend too heavily on one candle. The redundancy is the point a slow beat heard by many ears. He turns briefly to parameterizations that write the beat in a single symbol. The deceleration parameter, QZZ, negative today, positive in the past. Its zero crossing occurs near Z0, 5 under standard assumptions. The dark energy's equation of state parameters near 1 in the simplest cosmological constant model could in principle drift with redshift WZ/1, and that drift would bend both the distance redshift curve and the growth history. Current constraints keep you near 1 with small leeway. Some reconstructions flirt with mild evolution, but settle back under wider datasets. The simplest music resists ornament, yet the notation remains open for a grace note the next survey might hear. A lesser-known poetic detail glows at the edge of the stave in a decelerating universe. The light cone opens quickly and the particle horizon the furthest we can see grows rapidly, while in an accelerating universe, the event horizon the furthest we can ever influence settles into a finite distance. Thus, as acceleration deepens, tomorrow's reach shrinks even as yesterday's view keeps widening. The sky's archaeology improves while its diplomacy contracts. The diagram changes tone without changing key. He fits 3 more ironies where they barely rustle. Only took a subtle change in the early minutes, a percent-level energy density for a brief episode to shift rulers by enough that the present-day clock would change by hundreds of millions of years. Only took a flat global geometry curvature near 0 to make distance integrals simple, and yet the small residual disagreement still provokes the hardest questions. Simplicity highlights anomaly. Only took an extra neutrino-like species in a model to reconcile one ledger, and that addition then complicated others. Ease in one column tightens all the rest. He admits the patient practicalities because slowness asks for time. The redshift drift requires decades of stable spectrographs, locking onto narrow absorption lines in quasar spectra, measuring cumulative changes of centimeters per second per year. Biomeasurements at higher redshift need larger maps of the 3-dimensional distribution of galaxies and absorption systems clean enough to separate peculiar velocities from cosmological flows. Supernova standardization improves as rest frame infrared light curves grow, and dust laws become local rather than universal. Lens modeling strengthens with integral field spectroscopy of lens galaxies and deep imaging of line-of-sight structure. Cosmic chronometers demand better stellar population models with improved libraries spanning metallicity and age. Each path is a small engineering meditation on how to hear a slow metronome in a noisy room. He retains uncertainty as part of the calm. The Hubble tension may soften as parallax 0 points crowding corrections and TRGB calibrations converge. The growth tension may bend as shear calibration, intrinsic alignments and photometric redshift biases refine. Early dark energy parameter spaces that once seemed accommodating narrow under new background polarization and small-scale structure data. Exotic couplings in the dark sector write signatures into the cosmic microwave background damping tail or into halo mass functions. Yet the broad picture remains intact, a universe that decelerates then accelerates, a sound horizon that anchors scales, a late-time push that is smooth to the touch. Only the tempo's exact bars are still being tuned. A gentle modern analogy closes the paragraph without haste. He imagines walking a long beach at dusk as a tide turns. For hours the water has crept landward, filling shallow pools and tracing bright edges in wet sand. Then the line stalls and slowly, almost imperceptibly, it begins to retreat. The footprints of shorebirds mark both approach and withdrawal. and ripples on the sand fix the memory of a wave's last push. One cannot name the instant of reversal by watching a single crest, but scattered shells' dampness gradients and the angle of thin rivulets mark the change when the walk is viewed from end to end. The universe's slow beat is that turning tide first breaking, then easing out its markers scattered across wavelengths and epochs, its tempo read best by patience. He gathers the ledger the role requires and sets it down softly. One accepted fact: the universe passes from deceleration to acceleration near Z0. 5 with distances and growth, tracing a coherent L-shaped history. One poetic, lesser-known detail: the direct redshift drift, a planned measurement of a few centimeters per second per year, promises to feel acceleration in real time. One quiet scientific mystery: the linked tensions in the expansion rate and in the growth amplitude, and whether they signal hidden systematics or a small amendment to early physics. 3 soft ironies: a constant that is a curve, an acceleration that lengthens time while thinning structure, and quick supernova sketching an ancient beat. Only took a ruler from the first 1,000 years and candles from the last billion to score the song. Only took a whisper of pressure with the wrong sign to change the ending. Only took patience to hear that the tempo wavers where we once thought it held. He lets the slow beat continue even and unhurried into the next room where the first atoms keep their own counsel. He turns to the first chemistry the universe attempts a recipe written, when everything is still too young to have a name and a single accepted fact steadies the room in the first few minutes after the Big Bang, when temperatures fall from billions to hundreds of millions of Kelvin protons and neutrons bind into light nuclei, mostly helium-4 with traces of deuterium, helium-3 and lithium-7 yields, set almost entirely by the expansion rate and by the ratio of baryons to photons. This brief epoch of Big Bang nucleosynthesis ends quickly, leaves no heavy metals, and then coasts for hundreds of thousands of years until atoms can hold electrons and light can travel. He measures the memory because those ratios persist. When quasar light passes through clouds nearly untouched by stars, the hydrogen lines split into narrow notches, and tucked beside them a faint isotope-shifted echo of deuterium appears offset by about 80 kilometers per second. In the rest frame of the Lyman series, a tiny spectral whisper that when it repeats in multiple lines proves itself. From that offset, the primordial deuterium abundance emerges at a few parts in 100,000 of hydrogen, an exquisitely sensitive gauge of the baryon density. That number read in absorption against a galaxy that barely exists agrees with the baryon density inferred from the cosmic microwave background a few 100,000 years later. 2 clocks, one from minutes, one from recombination, match by design and by grace. A lesser-known detail folds into this, seeing the cleanest deuterium measurements come from high redshift, metal-poor, damped Lyman A systems, whose internal kinematics are quiescent enough that the isotope shift can be separated from velocity structure. The observers search for candidates where silicon and oxygen lines betray almost no enrichment, and where thermal broadening is modest. Only a handful of such sightlines are clean enough, yet the value they give is sharp. A billion-year-old quasar's light carries the fossil of a 5-minute summer. He keeps a quiet scientific mystery lying lightly across the page because one nucleus refuses to sit still. Lithium-7 predicted by the same equations and the same baryon density that nails deuterium and helium shows up in the oldest, most metal-poor stars at a factor of 2 to 3 less than expected. The lithium problem persists despite improved stellar atmospheres, diffusion corrections and reconsidered nuclear reaction rates. Perhaps lithium sinks below photospheres over giga-years erased from view by diffusion and turbulence. Perhaps early cosmic rays or pre-main sequence burning pruned it. Perhaps new physics touched that corner of the network. The faint plateau of lithium abundances across old halo stars remains lower than the primordial ledger would prefer, a soft mismatch that refuses to grow into drama, yet never disappears. 3 soft ironies arrange themselves at the rim of this quiet kitchen. First, the universe's inventory of anormal matter. One of the largest numbers in cosmology owes its precision to a spectral shift, only a few tens of kilometers per second wide, a wiggle in the violet that no eye could see. Second, the lightest, simplest nuclei, hydrogen's heavy sibling helium's steady mass, decide the parameters that set the growth of every later star and galaxy. The smallest chemistry fixes the widest future. Third, of all the nuclei that form in those first minutes, the one we might dismiss as a trace. Lithium causes the most trouble for theory, so the rarest ingredient keeps the recipe honest. He slows the pace to let the timeline breathe. After nuclear synthesis, the universe remains a hot plasma for hundreds of thousands of years, electrons, free photons trapped. As expansion cools the gas to a few thousand Kelvin protons, and electrons bind into neutral hydrogen and helium, recombination proceeds, and the mean free path for light leaps from microscopic to cosmological. The background glow decouples and streams, carrying with it the acoustic memory of the photon-baryon fluid and the densities that deuterium once recorded. The ages are far apart minutes for nuclei, hundreds of thousands of years for atoms, and yet the parameters match, because the same expansion rate and baryon fraction control both. Only took a single dial to tune 2 epochs. He places another delicate detail at the edge of the glass, the helium mass fraction Yp,
Starlight
the share of baryonic mass locked into helium-4, at birth lands near a quarter, about 0.24 to 0. 25 by mass measured not in our galaxy, but in extragalactic H2 regions,
The halo
where
looks
metallicity
solid,
is so
yet
low
it's made of
that
scattered
extrapolation to
stars
zero
pretending
enrichment
to
feels
be
fair.
continuous.
Emission lines of helium and hydrogen in those blue compact galaxies curve upward, with electron temperature and density and careful corrections, extract a primordial proportion that tracks background predictions. Helium glows in the present to confess the
Each
past.
cluster is an ancient
He listens
colony.
for how the
Its
first
stars
atoms
older than
remember
the
temperature
continents that
too.
now hold the
The
observer.
cosmic background spectrum is a near-perfect black body, cooled today to 2.7 Kelvin and measurements, at different redshift where dust and molecules imprint fine absorption, show that temperature scale rising as 1 pulses, a simple, elegant relation that confirms the adiabatic cooling of the photon bath. Against that cooling ladder, small deviations would broadcast energy injections or non-standard evolution. So far, the ladder holds. The background remembers with unembarrassed accuracy. Another trio of ironies walks by unhurried. Only took minutes of nuclear cooking to set the chemistry for billions of years, and only took billions of years of quiet for us to notice. Only took the first atoms to form so that light could finally leave, yet the memory we prize most, the background, comes from the moment photons stop telling us about matter. Transparency both reveals and conceals. Only took a handful of distant, nearly pristine clouds to tell us more about the beginning than nearby complicated gas could. Distance becomes simplicity. He turns one more time to lithium because its refusal is instructive. Stars with metallicities a thousandth of the sun's show, a spike plateau nearly constant lithium abundances over a range of temperatures and compositions, as though the primordial value survived everywhere and then was modified by the same process in the same way. Yet even if diffusion and gravity wave mixing deplete surfaces, comparably recovering the predicted primordial level for all such stars, strains credulity without more evidence. Nuclear experiments measuring the cross-section of beryllium-7 capture key to lithium production have sharpened rates, but the mismatch persists. The mystery remains a footnote with consequences if lithium is truly low at birth. The concordance of deuterium and helium with the background demands an amendment to physics.
The black hole's power is paradoxical. Its
If lithium is hidden
from what it
rather than
refuses
absent,
to show.
then stellar atmospheres and internal transport still need refinement. Both options keep patients employed. He looks for other relics that talk in the same voice. Helium-3, less abundant and more easily altered by stars, provides looser checks. Deuterium, destroyed in stars but never made in quantity, afterwards stays the gold standard. Its survival in unprocessed gas turns every low metallicity absorber into a laboratory. Even subtle isotope ratios in methane seen toward high redshift systems test the ladder that background and nucleosynthesis build. The web of confirmations grows where noise is least, not where light is most. Emptiness holds the cleanest chalk marks. A gentle analogy rests quietly. He thinks of a shallow tidal pool at dawn, the main sea withdrawn, leaving behind salt, fine silt and the delicate tracks of night creatures. From that residue one can read the strength of the tide and the wind hours before even the phase of the moon. The pool does not know the ocean's breadth, but it remembers its amplitude and timing. Deuterium in a quasar's line of sight, helium in a blue dwarf's glow, lithium in a halo star's photosphere, all are tracks left by the cosmos's first tide of fusion. Each tells phase and height, not horizon. He keeps uncertainties visible but scope limited. Systematic errors in deuterium measurements line blending velocity structure. Continuum placement can bias abundances if not modelled. Helium emissivity corrections and electron temperature determinations can shift YEP by small but important amounts. Background inferred baryon densities depend on a cosmological model where early dark energy or additional relativistic species would alter the calibration. Big Bang nucleosynthesis reaction networks carry residual uncertainties in
invisible
a few key
X-rays carry the
that still
conversation
matter at the
between the
percent level.
galaxy and the cluster.
Yet within these margins, the concordance remains one of the cleanest harmonies in cosmology. A baryon fraction determined from minutes-old fusion agrees with that from 100,000-year-old acoustics, and with that from the late-time counts of stars gas and weak lensing. The universe remembers itself across spans too large to compare by any other means. He adds a final triad of ironies to keep the cadence even. The background's perfect blackbody, shape and emblem of equilibrium, owes its perfection
The border that
to an
refused
era
to exist,
of violent scattering,
where
so
Messier
serenity
87
comes
ends
from
and the Virgo
chaos.
cluster begins. The eye
The most
cannot truly
primordial
tell.
places we study are not near but far, so the present must cross billions of years to approach the beginning. And the element that batteries and planets
Through
value
the
most for
embroidery
their
of
chemistry,
collisions,
lithium,
faint tidal
remains
shells
cosmology's
became the
least
galaxy's
obedient
delicate
tracer,
scars.
making the practical metal the philosophical nuisance. One accepted fact stands at the centre: the yields of Big Bang nucleosynthesis, especially deuterium and helium-4, match independent measures from the background and fix the cosmic baryon density with precision. One poetic, lesser-known detail hums at the edge the detection of primordial deuterium as a tiny isotope-shifted notch beside hydrogen, an 80 km/s echo that anchors a universe. One quiet scientific mystery persists: the lithium problem, a stubborn shortfall that refuses to choose between stars and new physics. Three soft ironies complete the ledger. The tiniest isotope shift weighs the largest inventory. Minutes decide billions of years, and the cleanest records live in the farthest, emptiest rooms. Only took first atoms to remember the pace of everything. Only took a few spectral threads to stitch minutes to millennia.
And a ring of photons
Only took a
sketches the
small
nearest
disobedient
thing to a
metal to
face
keep us from
darkness can
calling the
have.
story finished. He leaves the early chemistry where it already is short, exact and generous with memory, and lets the timeline drift
The
onward
halo
into the
looks
first
solid,
cities of
yet
light
it's
that
made
should
of
not be
scattered
there as early
stars
as they are.
pretending to be
He lets the first cities of light rise slowly on the dark plane, and in that dimness a single accepted fact steadies the hand. Telescopes now confirm galaxies when the universe is only a few 100 million years old. Redshifts greater than 10, some measured cleanly by their
Each
spectral
cluster is an
fingerprints
ancient
so that
colony.
distance is
Its
geometry
stars
not
older
guess.
than the continents that now
One of
hold
these
the observer.
JD's GZ130 sits at Z13.2, while an even earlier pair, JD's GZ14 and Z14-1, reach beyond 14, their ages written not in stories but in lines of hydrogen and oxygen that fall into mid-infrared and submillimeter bands today. He watches how evidence arrives from more than one instrument because ancient light needs multiple doors. The same Z14 galaxy that JWST fixes in near-infrared spectra also shows an 88 micron line in millimeter waves with ALMA, a cool fire that confirms both distance and oxygen already present in the
event
gas,
horizon
a
draws
quiet
no line,
sign that stars have
Yet
lived,
everything
burned and
around
returned
it
metals
obeys
even this
its
early.
silence.
A lesser-known detail glows in a different window at 7.7 microns, where JWST's MIRI can catch rest optical lines. The same record holder flickers with flux partly due to O3 and HV, a narrow proxy for whole factories of young hot stars. Models that fit this glow suggest stellar masses of order, a few 100 million suns within 300 million years after the beginning, a figure not impossible but brisk. He admits a quiet
The jet
scientific
shines
mystery
for
without raising
thousands
it,
of light years,
because calm
a cosmic
suits
filament
uncertainty.
drawn by
How do such
unseen
compact,
hands.
bright systems
Within
assemble
it,
so quickly
knots of brightness
through early
pulse
efficient
and drift,
cooling in massive
each
dark
a record of
halos,
past
a
feedings
star
at the
formation
core.
efficiency
HST-1,
that briefly
a
sharpens
luminous
a
knot,
top-heavy
once
initial mass
outshone the
function,
nucleus.
or
Proof
bursts
that even
fanned by
Gravity's edge
mergers,
flickers with
and how
memory.
often do emission lines and nascent black holes make starlight look heavier than it is. The ledger is still being corrected as mid-infrared data and line diagnostics revise masses downward in some cases. Three soft ironies pass like thin clouds. First, the galaxies that shouldn't exist by older expectations are demonstrated most securely, not by their
The
dramatic
black
images
hole's
but by
power is
narrow
paradoxical.
features,
Its
small
spectacle
lines
comes
settling
from what it
big
refuses
debates.
to show.
Second, the most distant systems sometimes look too massive, only because they're too alive nebular lines, and possible accretion light inflate their brightness so excess vigor masquerades as excess mass. Third, the earliest metals, oxygen seen in No3, arrive as calm confirmation that time has already passed there, so maturity becomes the evidence for youth. He lingers on how selection and correction share the same sky. In the first rush, bright rest optical emission falls into filters and paints galaxies as heavier than quiet starlight would allow. But mid-infrared points and spectra subtract that paint, revealing lighter, faster growing systems. Surveys that once counted too many giants now measure a more tempered abundance of truly massive objects after Z7 narrowing the gap with models without closing inquiry. He notes that confirmation reaches beyond a single survey. Spectroscopic programs across JD's and its companions keep pinning redshifts to lines, and press briefings translate that into plain speech, a galaxy scene. About 290 million years after the Big Bang, small and bright and forming stars quickly carries the record for a season, then shares
Where
it.
smoothness
Records
was
lean
born
toward being
from chaos.
verbs, not nouns. He lays down three more ironies to keep the pace level. Only took lines a few angstroms wide to place cities a few billion light years farther back than textbooks owned yesterday. Only took a mid-infrared whisper to correct a near-infrared shout, so the longer wavelength quiets the earlier excitement and steadies the number line. Only took oxygen in a place so young to prove that time moves quickly even when calendars have barely begun, because stars have already lived, died, and shared. He listens to theory without hurrying it because models breathe. Standard LCDM easily forms small halos early, and
Heat
building
that never
luminous
speaks.
galaxies inside them depends
Invisible
on gas
X-rays
cooling
carry the
paths,
conversation between
radiative
the
feedback,
galaxy
and the
and the
mapping
cluster.
between halo mass and starlight. Some early claims of contradiction relax as masses shrink and duty cycles shorten, but attention lingers at the bright end that invites careful revisions, perhaps brief windows of high efficiency, perhaps bursts clustered in time, perhaps gentle adjustments to early physics that also appear in other ledgers of expansion. A lesser-known detail threads through these revisions: time delay lensing, and the ladder that fixes present-day
The
expansion,
border that refused to
together with
exist.
early time
Where
background
Messier
fix, leave
87
little
ends
room
and
for
the Virgo
large
cluster
changes to
begins,
the cosmic
the eye
recipe.
cannot truly tell.
So any fix that shortens a ruler for high
Chemistry
redshift
of
galaxies
distance.
must keep deuterium, helium, and acoustic peaks in tune. In practice, that
Through
means
the
modest
embroidery of
early only
collisions,
energy
faint
components or
tidal
subtle
shells
dark
became the
sector
galaxy's
couplings
delicate
that
scars.
fade before structure growth matters most. The canvas is wide, the permitted brushstrokes fine. He keeps the room grounded in process rather than in surprise. The path from candidate to certainty runs through spectra that isolate Lyman breaks from interlopers, through line ratios that separate nebular glow from hot dust and accretion, and through ALMA detections that turn photometric redshifts into locked coordinates. At each step, the population changes shape but not existence. There are truly early
Its
galaxies,
edges fade
there is truly
like
early
memory.
metal, and there is truly rapid assembly at the edge of seeing. A gentle analogy keeps the scene quiet. He imagines tide pools forming on a shore as the very first tide turns. A few fill deeply and quickly in the first minutes, catching fish and reflecting stars, while others remain shallow until the second and third waves arrive. Looking back from the bluff, one might think the deep pools could not have formed so soon,
Starlight
until one
bends around
notices
it,
the narrow
and a ring
inlets
of
that funnel
photons
water
sketches
faster,
the nearest
and the
thing
rock
to a
shapes that
face
trap it.
darkness can have.
JabUST and ALMA show those inlets and shapes in light and line, and the early depth becomes less of a surprise and more of a map. He
The
leaves
halo
space for
looks
uncertainty
solid,
because
yet
Calm
it's made of
prefers honesty.
scattered stars
Some
pretending
reported
to be
record holders shift
continuous.
when deeper spectra appear. Some bright objects reveal accreting black holes that add light without adding long-lived stars. Some candidates at extreme redshift prove to be dusty imposters nearby. These adjustments are not retreat but refinement,
Each
a
cluster
slow
is an
focusing
ancient
of a
colony.
distant
Its
shoreline.
stars older than the
The headline
continents that now
calms and
hold
the
the
timeline
observer.
remains generous. One accepted fact sits at the center. The universe hosts spectroscopically confirmed galaxies at Zizos 10, including sources at Z14, with independent confirmations from rest optical and far-infrared lines. One poetic lesser-known detail glows at the edge, the 0388 micron line from a record-era galaxy, a quiet millimeter bell that rings across 13 billion years to say oxygen already breathes there. One quiet scientific mystery remains: how to divide early brightness among stars, nebular lines, and newborn black holes,
The event
and how
horizon
swiftly
draws
small
no
halos
line,
can turn gas into
yet
long-lived
everything
light
around it
without breaking
rebels
other
its
clocks.
silence.
Three soft ironies close the page. The earliest maturity looks like a paradox until the spectra lengthen. The strongest claims relax as data improve, yet the wonder persists, and the farthest confirmations arrive in the longest wavelengths, where cold instruments hear hot beginnings. Only took a telescope that sees heat to find cities where none were expected. Only took oxygen in a vacuum to prove that time has already cycled.
The jet
Only
shines
took
for
trimming a
thousands
mass
of
by a
light
factor
years,
of 2
a
to
cosmic
keep
filament
theory and sky
drawn by
in civil
unseen
conversation.
hands.
He
Within
lets the
it,
first cities
knots
keep
of
their light
brightness
small,
pulse
fast
and
and
drift,
exact,
each
while the
a record
shoreline of the early
past
universe
feedings at the
extends
core.
one more faint step into the
HST-1,
dark.
a luminous
He
knot,
turns to the
once
oldest
outshone
light
the
that still
nucleus,
arrives,
proof that
a
even
pale
gravity's
bath at
edge flickers with
2.7
memory.
Kelvin that fills every direction with the same quiet pressure, and an accepted fact steadies his grip. The cosmic microwave background presents a near-perfect blackbody spectrum with tiny temperature ripples. parts in
arcs linger
100,000
like
whose
fingerprints
pattern
on
of
glass
acoustic
time.
peaks encodes the early plasma's density expansion rate and geometry.
The black hole's power
This
is
fossil glow
paradoxical.
dates from the
Its
moment
spectacle
atoms
comes from
first
what it
hold
refuses
electrons
to
and
show.
photons decouple hundreds of thousands of years after the primordial fireball begins. Its smoothness establishes that the young universe is strikingly uniform, and its small roughness seeds every later galaxy and void. He lets the light speak in harmonics rather than in pictures because the sky becomes a score. Spherical harmonics decompose the temperature map into multipoles, each L describing structure on a corresponding angular scale, and the peaks and troughs in the angular power spectrum tell of pressure waves frozen at decoupling odd peaks marking compressions in dark matter wells. Even peaks marking rarefactions, baryons and photons oscillating together until the medium becomes transparent. From their positions he reads the sound horizon. From their heights he reads the baryon to photon ratio and matter content from the damping tail. He reads diffusion smoothing in the last scattering surface. The music arrives accurate enough that cosmology becomes metrology. A lesser-known detail glows in how this accuracy survives lensing. As background photons traverse the web of large-scale structure, gravitational potentials deflect them by arc minutes, subtly smearing peaks and transferring power from large to small scales. By reconstructing the lensing potential from the 4-point function of the temperature and polarization fields, in effect, letting correlated distortions betray the deflectors, astronomers map projected mass across half the sky without using a single galaxy's redshift. The oldest light becomes a surveying beam for structures billions of years younger, and the survey in turn confirms the background's own inferences about matter and neutrino sums within narrow corridors. He keeps a quiet scientific mystery alongside this precision, because even
Invisible
a well-tuned
X-rays
instrument
carry
has
the
overtones.
conversation between the galaxy
Several large
and the
angle
cluster.
features in the microwave sky sit oddly a low quadrupole power compared to model expectations, a planar alignment among the quadrupole and octopole that seems to point near the solar system's geometry, and a cold patch, an extended cold spot that some maps render deeper or more coherent than Gaussian statistics would likely produce. None alone rises above the strictest thresholds of improbability once a posteriori choices are acknowledged, and foregrounds and masks complicate inference.
Where Messier
Yet
87
together they
ends
hover
and the
as
Virgo cluster
unresolved
begins,
coincidences
the eye
small
cannot
enough
truly
to be
tell.
noise, large enough to invite patience.
Of distance.
3 soft ironies settle gently. First, the evidence
Through
that
the
the universe
embroidery
is
of
astonishingly
collisions,
simple
faint
on
tidal
the largest
shells became
scales
the
comes from the
galaxy's
very
delicate
sky
scars.
that also holds the odd cold spot, and aligned multipoles so simplicity and blemish share the same canvas. Second, the best detector of mass between us and the last scattering is massless light bent by gravity, so photons that weigh nothing weigh everything else. Third, the most persuasive black body ever measured, one that fits a single temperature to incredible precision, emerges from an epoch of intense scattering and turbulence, so perfection is the residue of chaos. He listens to polarization
Its
because the
edges
oldest light
fade
vibrates, not only
like memory.
shines. Thomson's scattering at last scattering imprints linear polarization, where local quadrupole temperature anisotropies exist, and those polarization patterns split cleanly into E modes, gradient-like, and B modes, curl-like. Scalar density perturbations generate E modes readily, but not primordial B modes. Those come from gravitational waves in the earliest
Starlight
fractions of a
bends around
second,
it,
or
and
from
a ring of
lensing that
photons
converts
sketches
E
the
into
nearest
B
thing to a
later.
face darkness
E
can
modes have been mapped and match the density-seeded picture with calming precision. B modes induced by lensing have been detected as
The
a
halo
soft
looks
background
solid,
consistent
yet
with
it's
the
made of
measured mass
scattered stars
distribution.
pretending to be
But primordial
continuous.
B modes' direct fingerprints of inflationary gravitational waves remain elusive at degree scales, their absence imposing tight limits on the tensor to scalar ratio, and therefore on the energy scale of the earliest expansion. The floor for dust foregrounds lies higher than once hoped,
Each cluster
and
is
the
an
sky's
ancient
cleanliness
colony.
varies
Its
with
stars
latitude.
older than the continents
The map
that
says
now
not
hold the
yet, and the
observer.
waiting becomes a method. He threads a lesser-known poetic detail through Ryonization's veil long after decoupling the first stars, and galaxies ionize the intergalactic medium again, and the liberated electrons rescatter some background photons, adding large-angle polarization, an optical depth fingerprint that lengthens the lever arm between the last scattering surface and now. The measured low optical depth implies a relatively late and extended reionization, a dawn that breaks gently rather than at once. Faint kinematic
The event
Sunyaev-Zeldovich
horizon
signals,
draws no line,
temperature tweaks from
yet
ionized
everything
gas
around
with
it
bulk motion
obels its
add a
silence.
second subtle signature of this era, turning patches of the sky into records of winds through filaments. The dawn leaves penciled marginalia in the oldest book. He sets 3 more ironies along the margin. Only took microkelvin fluctuations to fix the densities that govern everything bright, while Kelvin scale brightness tells almost nothing new. Only took the absence of a certain polarization curl to weigh an epoch too brief to name, so silence speaks as constraint.
The jet
Only took
shines
small
for
angle
thousands
smearing
of
by
light
lenses
years,
to sharpen
a
our
cosmic
knowledge of
filament
neutrinos and
drawn
dark
by
matter,
unseen
so
hands.
blur improves focus.
Within it,
He sits
knots
with
of
ancillary
brightness
imprints
pulse and
that
drift,
modulate the background
each a
without
record of
complaining the
past
integrated
feedings at the
Sachs-Wolf
core.
effect,
HST-1,
where potentials decay in a
luminous
dark
knot, once
energy-dominated
outshone the
era
nucleus,
and impart
proof
net
that even
energy
gravity's
shifts to
edge
crossing
flickers with
photons,
memory.
correlates large angle temperature maps with nearby galaxy distributions. The thermal Sunyaev-Zeldovich effect, where hot cluster electrons boost photon energies, draws a climatology of hot gas across the sky. Spectral
arcs linger
distortions,
like
though not yet
fingerprints on
measured
the
beyond
glass of
stringent
time.
limits, would register any energy injection that breaks the pristine black
The
body
black hole's
M-type
power is
at early
paradoxical.
times,
Its spectacle
Y-type
comes
at
from
later
what it
turning
refuses to
departures
show.
from perfection into timestamps for exotic heating. Each of these effects rests like a faint fingerprint on the same smooth sheet, and each checks the consistency of stories told elsewhere. He returns to the anomalies without letting them swell. The cold spot could arise from a chance superposition of hot and cold modes in a Gaussian sky, or from a Rees-Siyama imprint of a large-scale underdensity. Those surveys measure no void large enough to shoulder all the blame. The quadrupole deficiency may be no more than a fair coin landing on tails a few times in a row, and the low-L alignments may dissolve when better foreground models and masking schemes rotate the basis. The scientific posture becomes one of watchful indifference. Note quantify, do not anchor conclusions to rare events. A gentle modern analogy holds this stance. A potter examines a fired bowl, whose glaze emerged almost uniformly with only a few faint drifts where minerals pooled. The bowl's symmetry proves the kiln's steadiness. The drifts prove the reality of process. No crack appears. No warp, only the record of heat and time. The background is that bowl useful precisely because it is almost featureless. Interesting because it is not perfectly so. He carries uncertainty openly but within limits. Cosmic variance on the larger scales means that for low multipoles the universe's single sky is a small sample, and probabilities have fat tails. Component separation removing galactic dust and synchrotron foregrounds relies on spectral indices that vary across the sky, and residuals can mimic anomalies if misestimated. Instrument beams and noise correlations need exquisite modelling to avoid leaking power between E and B. Yet after such housekeeping, the LCDM fit to the full temperature, and E-mode spectra still sit
Heat
squarely
that never
within error
speaks.
bars.
Invisible
Discord
X-rays
survives
carry
mostly
the
at low L and
conversation
mostly
between
in
the
mood.
galaxy and
He
the
adds
cluster.
a thin line of chemistry where it touches the oldest light. The fine structure lines of ionized carbon and neutral oxygen in early galaxies seen in millimeter waves today trace regions that also absorb and emit against the background. Cross-correlating these lines with the microwave sky can in principle map patches of rionization geometry, turning the uniform bath into a lightly stippled wash. The background partners with its descendants to narrate a single surface viewed through time.
The border that refused
Three
to exist,
final ironies
where
pass
Messier
without
87
raising their
ends and
voices.
the Virgo cluster
The
begins.
black body's
The eye
absolute
cannot truly
temperature,
tell.
2.725 K, matters less to parameter fits than the relative ripples, so the biggest number carries the smallest weight.
Through the embroidery
The
of
cleanest
collisions,
confirmation
faint
of
tidal
Big Bang
shells became the
thermodynamics
galaxy's
requires
delicate
instruments
scars.
flying above the very atmosphere that made life possible. So the air that sustains us complicates the measurement of the air that once was everywhere, and the background that convinces us the universe is finite in age refuses to show us anything from before transparency. So the light that proves a beginning also hides it. One accepted fact stands like a stone. The cosmic microwave background is a near-perfect black body with microkelvin anisotropies, whose power spectrum fixes the universe's contents and geometry with remarkable precision. One poetic, lesser-known detail hums at the edge. The lensing reconstruction of the microwave sky uses the four-point function to draw a projected mass map without a single galaxy's distance, letting the oldest light weigh the Middle Ages. One quiet scientific mystery remains large angle anomalies and the still absent primordial
The halo
B-mode
looks
oddities
solid,
and
yet it's made of
silences that could
scattered
be
stars
statistics
pretending to be
systematics or a hint
continuous.
of physics older than the last scattering's bright hush. Three soft ironies close the page. The most certain canvas hosts the most famous blemish massless light draws the map of mass, and a perfect spectrum is the fossil of violence. Only took a few parts in 100,000
Each
to seed
cluster
100
is an
billion
ancient
galaxies.
colony. Its
Only
stars
took a
older than the
gentle curl
continents
that
that
never
now hold
quite
the
appears to
observer.
measure a storm that may have happened before light could travel. Only took lensing's blur to refine clarity. He lets the oldest light continue glowing at the floor of all rooms, its smoothness carrying structure, its anomalies teaching restraint, its silence leaving the door to older unlabeled but slightly ajar. He spreads the calendar until the numbers soften and become a fabric. Because in cosmology, time does not march, it stretches, and an accepted fact steadies the weave cosmic time, since the hot beginning follows from integrating the inverse expansion rate TL
The event horizon draws no line,
PHZ.
yet everything
So
around
age is not
it
a single guess, but
rebels
the area
in
beneath the
silence.
curve, its value set by matter radiation, and the dark energy that bends the plot, under the standard spatially near-flat model, with a cosmological constant and cold dark matter, that integral yields about 13.8 billion years, a result tied to the same parameters that the oldest light and the low redshift distance ladder keep cross-checking. He listens to geometry because shape and time tie knots in the same thread. Spatial curvature, if present, would tilt distances at fixed redshift and alter the
jet
integrals
shines
area,
for thousands
making
of
the
light
universe
years,
older or
a
younger
cosmic
for the same
filament
ETH
drawn
0.
by unseen
Background
hands.
maps, baryon acoustic
Within it,
oscillations and
knots of
lensing
brightness, pulse,
prefer
and
curvature
drift,
so small
each a
that
record
flat
of
space
past
is a
feedings
serviceable
at the core.
sketch. A near-zero
HST1, a
Gaussian
luminous
curvature
knot,
that lets
once
great
outshone the
circles be
nucleus,
straight enough
proof
for work.
that even gravity's edge
Yet the
flickers with
calculus
memory.
remains a reminder. Age is an integral over history, not a clock on a wall. A lesser-known detail lives where the algebra changes clothes. Cosmologists sometimes draw the universe in conformal time he defined, so that light rays run at 45 degrees on the diagram, compressing the first hundreds of thousands of years into a wide porch and stretching late epochs into a
The
shorter
black hole's
hallway.
power is paradoxical.
In that metric
Its spectacle
recombination
comes from
sits
what it
at a
refuses to
finite well
show.
before today. and horizons become lines one can draw with a ruler. The poetry is practical, conformal. Time trades seconds for angles, so that causality reads as geometry, and the primordial acoustic waves that imprint the microwave sky travel simple paths. The first light looks less like a date and more like a surface. He keeps a quiet scientific mystery folded along the hem, because the integron that sets age could dip or bulge at early times in ways still under test. Proposals for an early dark energy episode raise the expansion briefly near recombination, shrinking the sound horizon to reconcile rulers without changing late distances too much, while leaving nucleosynthesis and structure growth intact. Other ideas nudge the dark sector, mild interactions, evolving equations of state, or extra radiation-like species in ways that adjust HZ, where data are hardest to pin. Each small change shifts the area under the curve and therefore the age, but every change also leaves fingerprints elsewhere on the damping tail of the microwave background, on growth rates and lensing amplitudes, on the detailed shape of baryon acoustic features. The fabric allows embroidery not tearing, and the stitching is inspected under bright lamps. 3 soft ironies settle with the lint. First, an age written to tenths of a billion years depends on integrals whose inputs are measured both from the first 1,000 years after the beginning and from candles that died last week, so the youngest events mend the oldest numbers. Second, the parameter called equation of state for dark energy. The ratio of pressure to energy density sits near 1, and thereby acts like a constant vacuum, and the constancy that keeps age stable is the property with the least human intuition. The most mysterious thing is the thing that makes our
invisible
arithmetic
X-rays
easy.
carry the
Third,
conversation
spatial
between the
flatness
galaxy
so
and the
convenient for
cluster.
drawing means the universe is infinite, or at least very large in extent, even as it is finite in age. So a geometry that seems simple turns into an irony, endless, room-limited time. He lets alternative gravities pass by with respect and a measured pace. Modifications to general relativity at large scales, functions that change how curvature responds to matter, extra fields that couple weakly to the metric, could in principle alter growth and
The border that
distances while
refused to
keeping
exist,
early universe fits
where Messier
intact.
87 ends
They
and the
offer
Virgo
a route
cluster
to
begins,
reweaving the
eye
fabric without
cannot
adding
truly
new
tell.
threads to the early plasma. Yet they too confront overlapping ledgers, solar system tests, binary pulsar timing, gravitational
Through the
wave
embroidery of
propagation
collisions,
speeds,
faint
and the equality
tidal
of
shells
lensing and
became the
dynamical
galaxy's
potentials on
delicate
cosmic
scars.
scales. So far, the standard metric carries the weight calmly. Departures are limited to margins that bend the age by little, unless joined by other changes. He pauses over the dependence that hides in plain sight increase the present expansion rate, H0 with all else fixed, and the integral shrinks the calendar shortens. Lower H0 with all else fixed, and the calendar lengthens. Tilt W above, 1 and dark energy dilutes faster, letting matter decelerate for longer, and raising the age at fixed
like
H0.
memory.
Tilt W below, 1 and the opposite happens. Let curvature go negative open and distant objects sit farther for the same redshift, altering the fit and the inferred age. Let curvature go positive closed and the reverse. The couplings are entangled so Bayesian fits trade one knob against another until external rulers fix the slack. The age is thus not a
Starlight
free
bends
poem
around
but a
it,
constrained
and a ring
stanza.
of photons
A second
sketches
quieter
the nearest
detail
thing
holds
to
its
a
own
face
shimmer.
darkness can
The
have.
look-back time to a given redshift differs from the light travel distance divided by c, because hz changes along the path. In a sense,
The halo
photons
looks
age
solid,
by the integral
yet
while
it's
we
made of
imagine
scattered
distance as a
stars
snapshot.
pretending to be
This difference is
continuous.
not a correction but a definition, and it matters when a sentence says we see the galaxy as it was. X billion years ago, that number is an integral, not a guess, and the curve's shape gives it. He parks 3 more ironies along the selvage.
Each cluster
Only
is
took
an ancient
microkelvin
colony.
ripples on a
Its
2-point
stars older than
function
the
to
continents
set the
that now
curvature
hold
that
the
keeps
observer.
triangles Euclidean in a universe that is anything but small. Only took a vacuum pressure we do not understand to stabilize an age we quote as though it were a birth certificate. Only took writing the metric in a different coordinate conformal time to make the earliest epoch look closer than the last half of history. So choice of ruler changes the sense of nearness without moving anything. He carries the thread to structure because growth too uses the same hz. Linear perturbations obey a differential equation, whose friction term is the expansion
draws
rate.
no line.
So faster,
Yet everything
expansion
around it
slows the
obeys
build-up of
its
contrast, and
silence.
slower expansion allows more clumping. This coupling is why the mild tension in growth seen by weak lensing maps speaks in the same room as the Hubble tension. Any early time change that adjusts distance rulers must keep growth's later melody in tune. Write these in conformal Newtonian gauge or in synchronous form, and the algebra differs while the content remains. The fabric remembers how hard it was to wrinkle at each epoch and wrinkles are galaxies. He lays down the gentlest analogy not to prove, but to feel. Imagine a broad rubber sheet with a faint regular grid drawn on it.
Within it,
One multiplies
knots
the
of
sheet's
brightness
scale
pulse
without
and
stretching the
drift,
Inca
each
conformal
a
map,
record of
and
past
straight
feedings
lines
at the
remain
core.
straight.
HST1,
Draw a circle around a
luminous
point and
knot,
watch it
once
grow,
outshone
while
the
angles
nucleus,
at the point
proof
keep their
that
sum.
even gravity's edge flickers
Now add a
with
few
memory.
small weights that dimple the sheet. Those are halos, while a slow hand pulls the frame outward. Dark energy so that the dimples deepen and then shallow in relative depth as the sheet accelerates. The age of the sheet is not the time on the hand's clock,
Their
but the
arcs
area
linger
under the
like
curve of how
fingerprints
fast the
on
frame
glass of
moved.
time.
The picture holds enough to carry a feeling without claiming more. He returns to
black
the
hole's
theme of
power is
older than we
paradoxical.
imagined with
Its
restraint
spectacle
because the
comes from
fabric
what it
invites
refuses
but
to
also
show.
limits. To push age upward significantly while honouring nucleosynthesis and the background's acoustic ledger would require small early adjustments that integrate to more time between the first light and now without breaking the rulers we have set. Options exist early: dark energy pockets, mild extra radiation, subtle curvature within current bounds, but each adds complexity that must be paid for in other columns. For now, the standard weave holds its age near 13.8 billion years, a stable consequence of many lines braided together. The possibility of extra minutes or hundreds of millions of years remains a technical, not a dramatic conversation. Uncertainty remains present as texture, not as storm. The Hubble tension keeps the late time end of HZ a few beats above the early time inference. The growth amplitude sits a hint low compared with the background-tuned model. Spectral distortions of the background, M and Y types, remain upper limits that still allow early gentle heating episodes. Redshift drift measurements wait for decades of patience to write a direct derivative on the page. Each
Where
uncertainty is an
smoothness
invitation
was
to
born
measure, not a
from
license to
chaos.
invent. He lets a final triad of ironies drift by unannounced. The model that treats the vacuum as constant grants the universe more time than a varying vacuum designed to be more physical might. The coordinates that make causality clearest conformal time make the word age feel less like a number and more like a map turning when into where. And the better we measure the curve HZ, the less we need the word beginning. Because the integral does the speaking age emerges from shape, not from a story. Only took an area under a function to fix the calendar. Only took near flatness to turn miles into
Heat
lines.
that never
Only
speaks.
took a parameter close to
Invisible
1 to keep
X-rays
the
carry
fabric
the
even.
conversation between
He
the
leaves
galaxy
the cloth
and the
uncreased,
cluster.
thin, smooth and stitched to the same horizon as before, ready for the first darkness between stars to speak in its own low register about how long silence lasts before light begins. He dims the lantern until even starlight leaves the room, and in that deep hush, An accepted fact steadies his touch after the last scattering surface, and before the first luminous sources ignite, the universe enters a long interval when neutral hydrogen fills space and no stars
The border
exist.
that refused to exist.
The cosmic
Where
dark
Messier
age is
87
ending
ends
only
and the
when
Virgo
nascent
cluster
objects
begins.
light the
The eye
fog and
cannot
begin
truly tell.
realization. Between those
Chemistry
bookends,
of
time
distance.
stretches across hundreds of millions of quiet years, and the only natural beacon is the hydrogen spin
embroidery
flick
of
transition at
collisions,
21
faint
centimeters
tidal
redshift
shells
is
became
brigade
the
into
galaxy's
meter-long radio
delicate
waves.
scars.
He lets the physics of that single line speak softly, because one number guides the entire nocturne. The hyperfine levels in neutral hydrogen's ground state parallel and anti-parallel spins of proton and electron separate by an energy corresponding to 21 centimeters, and the ratio of those level populations defines a spin temperature. If that spin temperature is driven by the microwave background alone, the gas stays invisible against it. If collisions or the Wout-Hyson field effect resonant scattering
Its
of
edges
Limoner
fade
photons from the
like
first stars,
memory.
couple the spin temperature to the colder or warmer kinetic temperature of the gas, the line appears in absorption or emission against the background. As the gas cools adiabatically after recombination and then later heats through X-rays from early remnants, the 21 centimeter contrast traces a cosmic weather map: cold darkness, then gentle warming, then the slow erasure of neutral
Starlight
hydrogen
bends
by
around
growing
it,
bubbles of
and a ring of
ionized
photons
light.
sketches
A
the
lesser-known
nearest thing
detail
to a
rests in
face
the air of
darkness
deserts
can
and
have.
polar plateaus. To hear this long wave, instruments retreat from hum and glare to radio-quiet zones, where the Earth's ionosphere
The
barely
halo looks
stirs,
solid,
and human
yet it's made of
transmissions fall
scattered
below the
stars
horizon.
pretending to be
Arrays of
continuous.
simple dippoles. Hera in the Karoo Lofar across the Low Countries, NWA in Western Australia, listen to a sky that is in truth blindingly bright at these wavelengths because of galactic synchrotron emission. Foregrounds exceed the signal by orders
Each
of
cluster is an
magnitude,
ancient
smooth in
colony,
frequency,
its stars
but
older than the
corrugated on the
continents that
sky,
now hold the
so the
observer.
measurement is an exercise in subtraction and patience, turning the uniformity of contaminants into a handle for peeling them away while preserving a cosmological whisper beneath. He keeps a quiet scientific mystery in the heart of the room because the first claimed detection of a global absorption trough arrived with a depth that seemed too deep for the standard thermal history, a flattened dip near 78 megahertz, roughly a redshift of 17, reported by a small, carefully calibrated instrument, interpreted as hydrogen colder than expected against the background. Explanations
The event
proliferated to
horizon
meet the
draws
depth.
no line.
Perhaps the gas
Yet
was
everything
extra
around it
cooled through
obels
interactions
its
with
silence.
dark matter. Or perhaps the background was brighter than the cosmic microwave alone, radio-loud early black holes rendering the contrast stronger. Later experiments independent global signal instruments, with different systematics and careful ground plane controls, did not reproduce the amplitude, and the debate settled into method. The trough's timing and shape remain plausible, its depth remains unsettled. As arrays move
The
from
jet
single
shines
number
for
global
thousands of
measurements
light
to
years,
maps of
a
fluctuations,
cosmic filament
the field
drawn
leans
by
towards spatial
unseen
power
hands.
spectra and tomographic
Within it,
slices,
knots
yet the
of
quiet
brightness
question
pulse
stays
and
how
drift,
cold exactly
each
is the
a
night
record
before
of
the
past
first dawn.
feedings at the core.
3 soft
HST-1,
ironies slip by
a
like low
luminous
clouds.
knot, once outshone the
First, the
nucleus,
cleanest probe
proof
of the
that
Dark
even
Ages
gravity's
uses a
edge
line so
flickers with
common
memory.
that it threads through every radio receiver on Earth, yet that ubiquity makes it the hardest signal to isolate. Abundance breeds difficulty. Second, the era with no stars offers the richest three-dimensional map in principle. Every
Their arcs
redshift
linger
slices
like
a new
fingerprints
shell,
on the glass
so
of
emptiness
time.
promises the most data. Third, the earliest light does not appear first in
The black
images,
hole's power
but
is
as a change
paradoxical.
in a coupling
Its spectacle
coefficient
comes
between
from
a
what it
spin
refuses
system and
to
a
show.
bar. So dawn begins as a temperature ratio, not a sunrise. He watches the sequence play out in slow, quiet steps. After recombination, the gas cools faster than the microwave background, And while density remains high, collisions can couple spin, and kinetic temperatures briefly producing shallow absorption. As expansion loosens collisions, the line fades into invisibility. When the first stars begin to shine in ultraviolet, their Lyman photons scatter in the intergalactic medium, and via the Wout-Hyson field effect recouple the spin system to the cold gas-deepening absorption across vast volumes, the cosmic Lyman coupling era. Later soft X-rays from early binaries, mini-quasars, or supernova-heated halos warm the neutral gas, lifting the spin temperature above the background and flipping the line into emission in the X-ray heating era. Finally, ionized bubbles grow and merge, and the neutral signal disappears inside hot, transparent cavities until only pockets remain in the late reionization drizzle. The 21-centimeter sky thus offers three movements: coupling, heating, ionization, each with its own map written in contrast rather than in colour. He lingers on instruments that translate rhythm into pattern without rushing their cadences. Interferometric arrays measure fluctuations, angular power spectra, and ultimately images by cross-correlating antenna pairs across many baselines. Their sensitivity improves with collecting area, and with drift scan hours under calm ionospheric conditions. Bandpass smoothness, beam chromaticity and calibration, stability become the quiet instruments of a craft closer to carpentry than to spectacle. Even thermal noise falling with the square root of time encourages the same behavior as the science itself, patience. And here a lesser-known detail glows. The Earth's ionosphere refracts meter waves differently with time of day, season and solar weather, introducing slow geometry and rapid phase to the signal. Planners court minima nighttime in winter, solar quiet and model the rest. Hearing the universe's sleep requires waiting until the atmosphere is asleep as well. He lets uncertainties remain on the table where they belong. Foreground subtraction risks mixing spectral structure from instrument beams and the ionosphere into what should be smooth, thereby carving artificial troughs or bumps. Calibration noise can correlate across frequencies in ways that mimic cosmological variance. Reflections between antennas and ground planes imprint faint ripples that align too neatly with the targeted band. Cross-checks redundant baselines, sky rotation synthesis in situ beam mapping. End-to-end simulations shore up conclusions, and the instruments now closing on first detections of reionization-era power spectra carry those checks like charms. The Dark Ages themselves, earlier and harder to reach, wait a little longer behind brighter foregrounds and thicker ionospheres. The ledger stays open. 3 more ironies line up with the dipoles. Only took a technology that looks like a field of clotheslines to ask a question about the universe's first century of millions of years. Simplicity scales. Only took measuring nothing, no stars, no galaxies, to learn the schedule of when everything begins. Absence is calendar. Only took the same hydrogen that later fuels stars to narrate the time when stars do not exist. Fuel becomes historian. He returns to the thermal story because temperature is the protagonist when light sleeps. Adiabatic cooling sets the floor until the first heating turns on. The mix of X-ray sources, high-mass X-ray binaries with spectra that travel far or compact accretors with harder output sets. How uniform the warm-up becomes softer. X-rays heat near their sources and produce patchy maps. Harder X-rays smear more evenly. The depth and timing of the absorption trough and the slope of the rise into emission together constrain this invisible population. The same early sources likely seed weak radio backgrounds or inject relativistic particles that also alter coupling. Any one knob moves several gauges, so the 21-centimeter line becomes a joint interrogation of astrophysics and cosmology. Star formation efficiency, initial mass function of the first stars, X-ray luminosity per unit, star formation, dark matter interactions, if any, and the spectral history of heating all leave different fingerprints in frequency
The
and
event
angle.
horizon
A
draws
gentle
no
modern
line,
analogy rests
yet
at hand.
everything around it
He imagines a
obels
vast lake at
its
winter
silence.
dawn, iced thin but unbroken. A wind begins far away, and ripples run under the ice before cracks form. The ice darkens where it chills, fastest grows grey, where distant campfires and moonlight soften the sheet, and then thaws from scattered inlets outward. Standing on a bluff, one could in principle time the hidden wind by watching the greyness advance without seeing the wind itself. The 21-centimetre sky is
The
that
jet
greyness, no
shines for
flames,
thousands of light
visible
years,
only their
a
influence
cosmic
upon a
filament
single tone
drawn
that
by
runs beneath
unseen
the scene.
hands.
He folds in
Within it,
cross-checks because
knots
one
of
signal does
brightness
not walk
pulse and
alone.
drift.
High
Each a
redshift
record
galaxy
of past
surveys count
feedings
rest
at the core.
ultraviolet sources that should drive
HST-1, a
Limoner
luminous
coupling,
knot,
while
once
Limoner
outshone the
emitters
nucleus.
themselves thin
Proof
where
that even
neutral
gravity's
fractions
edge
rise.
flickers with memory.
The kinetic Sunyaev-Zeldovich effect from patchy reionization adds small-scale power to the microwave background. Quasar-damping wings at Z7 set snapshots of neutral fractions along rare bright sight lines. These
Their
indirect
arcs
probes
linger
frame
like
the time window
fingerprints
in
on the
which the
glass of
21-centimetre map must evolve, keeping fantasies in scale and turning a hard
The
measurement
black
into a
hole's
constrained
power is
story.
paradoxical.
He leaves a
Its
place for the
spectacle
next
comes
instrument,
from what it refuses
because
to
the
show.
field's patience has an endpoint. The square-kilometre array will multiply, collecting area-widened bands, and deepen calibration to the level where both power spectra and images of ionized bubbles become routine. Dark Age tomographic ambitions that feel like poetry, now mapping structure before stars become engineering problems. Once the ionosphere, the bandpass and the beam accept their roles. Even lunar farside concepts hover as very long-term dreams, a radio-quiet hemisphere in permanent night for the lowest frequencies where Earth's sky refuses cooperation. Ambition here keeps the tone low by necessity. Schedules measure in years results in careful steps. He gathers the ledger the role requires in a single even breath. One accepted fact. The universe passes through a starless dark age when neutral hydrogen can in principle be mapped in its 21-centimetre line with Limoner coupling X-ray heating and reionization, writing a 3-act script in frequency and angle. One poetic lesser-known detail: the measurement thrives best in silent places where ground planes are smooth and winter nights keep the
Where
ionosphere
smoothness
calm,
was
so the
born
quietest
from
terrestrial
chaos.
air becomes a partner to the quietest cosmic epoch. One quiet scientific mystery: whether the global absorption really deepens beyond standard expectations, and if so, whether extra cooling or a brighter early radio background or neither explains the depth. 3 soft ironies: the most informative era contains no visible objects. The most common atom becomes the most delicate messenger, and the noisiest foregrounds mask the faintest, smoothest signal. Only took a metre-long whisper to time the first fires. Only took a coupling between spins and
never
scattered
ends.
photons to define a dawn. Only took waiting
Heat
for a
that
night
never
to be
speaks.
quiet enough on Earth to
Invisible
hear how the
X-rays
universe
carry
slept.
the conversation
He
between the
leaves the
galaxy
radio
and
field
the
under
cluster.
the same stars that will later fill his story, and lets the unlit lake of hydrogen hold its temperature a little longer before the first inlets of light begin to thaw it. He walks into the interval when darkness begins to manufacture its own ending, and an accepted fact steadies the room. The first generation of stars forms from gas with no heavy elements. Population 3, so cooling, proceeds through molecular hydrogen lines and without metals or dust to shed heat efficiently.
The
The
border that
typical
refused to
fragments are
exist.
large.
Where
The
Messier
stars
87
that condense
ends and
are
the Virgo
thought to be
cluster
massive
begins,
and
the eye
short-lived,
cannot truly tell.
pouring ultraviolet light into their
Chemistry
surroundings
of
and dying
distance.
within a few million years in bright explosions that synthesize the first
Through the
oxygen,
embroidery
carbon,
of
magnesium,
collisions,
and in
Faint
some
tidal
cases
shells became
iron.
the galaxy's
He listens to
delicate
how an
scars.
absence teaches, because metal-free is not silence. In gas without heavy atoms, rotational vibrational lines of H2 provide the main coolant down to a few hundred Kelvin, setting a characteristic mass for collapsing fragments that is heavier than the pieces favoured later. Simulations that allow Lyman-Werner radiation to dissociate H2 dust, to arrive after the first explosions and turbulence to stir halos, still tend to gather their first lights by the dozen in mini-halos of a few 100,000 to a few million
Its edges
suns.
fade
Those
like
stars
memory.
live briefly carve H2 regions and end as core collapse, or when masses land in a narrow high window, near 100 to a few hundred suns, as pair instability supernovae, whose thermonuclear pulse disrupts the entire star. The yields from those deaths, salt surrounding gas with patterns of elements that do not resemble any later furnace exactly. A lesser-known
Starlight
detail
bends
glows in
around it,
one line that
and
the
a
first
ring of
stars may leave in
photons sketches the
ionized gas
nearest
around
thing
them.
to a face
The
darkness can
Estundum
have.
1640 angstrom recombination line bright, when extremely hot metal-free stars flood helium with energetic photons,
The halo
serves as
looks
a narrow
solid,
beacon
yet
for
it's made
primordial
of scattered
hardness.
stars pretending
Searches
to
for
be
this feature in
continuous.
high redshift galaxies continue with non-detections and tentative hints together, placing upper limits on the prevalence of truly metal-free clusters. The absence of a loud He2 chorus does not mean the first stars do not sing, it constrains how many sing at once.
Each
How
cluster
quickly
is
the
an
first
ancient
metals
colony.
quiet the
Its
choir,
stars older than
and
the
how
continents
often
that now
nebular
hold the
geometry
observer.
hides the sound. He keeps a quiet scientific mystery in the genealogy, because the initial mass function of population 3 remains unmeasured. Did it peak near tens of suns or near 100? Did a tail to low masses exist that would have left a few survivors still orbiting in the Milky Way's halo today? And how often did their deaths take the pair instability route, with its distinctive iron-rich yet neutron-poor yields, versus the core collapse path that can trap iron in fallback and eject lighter elements in abundance? The answers matter because they decide how
The event
quickly the
horizon
universe leaves
draws
its
no
first
line,
poverty behind,
yet
and how the
everything
first
around it
black hole seeds
obeys
for later
its
giants
silence.
first appeared. 3 soft ironies settle like small stones along a stream bed. First, the briefest lived stars decide the longest lived chemistry explosions lasting seconds, set element ratios that persist in faint halo stars for 13 billion years. Second, the most massive early stars blazing hot and metal-free remain invisible to us, not because they were dim, but because they are gone. Brightness ages into traces
The jet
fainter than a
shines
whisper.
for thousands
Third,
of light years.
the poorest gas
cosmic
devoid of
filament
metals
drawn
becomes the
by
richest
unseen
teacher,
hands.
because scarcity
Within it,
forces paths whose
knots of
signatures are
brightness
easiest to
pulse and
recognize
drift.
later.
Each
He lets
a record of
archaeology
past
take the lead
feedings
where
at the
telescopes
core.
cannot, because fossils
HST-1,
remain where
a luminous
firelight does not.
once outshone the
Extremely
nucleus.
metal-poor
Proof that
stars
even
in the
gravity's
Milky Way
edge
halo
flickers with memory.
subgiants and dwarfs with iron, abundances 1,000th to a 10,000th of the Sun, carry in their atmospheres the yields of one or a few first supernovae. Their spectra show large enhancements in carbon relative to iron, odd-even
Their
patterns
arcs
in
linger
intermediate
like
mass
fingerprints
elements,
on the glass
and at
of
the
time.
lowest metallicities, an absence or great rarity of heavy neutron capture elements.
The black hole's
Objects
power
such as
is
SMSS,
paradoxical. Its spectacle
JO313,
comes from what it
6708,
refuses to show.
and HE 13270-2326 display iron so low it becomes an upper limit, while carbon and magnesium stand tall, a language consistent with faint mixing and fallback core collapse explosions that launched light elements while swallowing much of the iron back into the remnant. In other cases, moderate iron with a strong odd-even effect hints at pair instability yields. The sky's oldest small lights read like marginal notes left by dead titans. He sets a lesser-known threshold quietly on the table, the critical metallicity for forming long-lived low-mass stars set either by fine structure cooling in carbon and oxygen, or by dust grain emission
Even
lands near
distant
10.5 to
galaxies
10.3, of the sun's metallicity. Chemical D trans criteria using carbon and oxygen abundances show that many ultra-metal-poor stars cross this threshold, implying that one or a few first supernovae seeded pockets just enough to let the next generation fragment into smaller masses. Dust made in those first explosions, even if fragile, may have provided the last step downward in temperature. Thus, the universe's patience with small stars begins with a sprinkling of ash. 3 more ironies drift past with the same low current. Only took a pinch of carbon and oxygen parts per million by mass to change the stellar census from giants that die young to dwarfs that live for the age of the universe. Only took dust from the first explosions to allow the first truly long-lived stars to form, so death becomes the welcome that lets longevity begin. Only took a single faint star in our halo to summarize the life of a star so bright it could not hide if it still existed. The least conspicuous witness testifies most. He runs a finger along the different deaths, because the ledger distinguishes pair instability supernova yield element patterns with strong odd-even contrasts and a lot of iron, but they produce almost no neutron capture elements. Faint core collapse supernovae with mixing and fallback throw out carbon, oxygen and magnesium but little iron. Jet-driven explosions and rotating progenitors complicate patterns and may imprint nitrogen in excess. Some early compact binaries may even launch gamma-ray bursts, whose afterglows, if they occurred, then would have ionized and heated pockets before disappearing. The mixture of these channels integrated over the first few hundred million years sets the distribution of carbon-enhanced metal-poor stars, the frequency of our process enrichment, and the baseline for the first low-mass survivors. He listens for our process whispers because the heaviest elements become stamps of origin.
Through the
While
embroidery
many of the most
collisions,
iron-poor stars
faint
lack
tidal
neutron
shells
capture
became the
elements,
galaxy's
others
delicate
like those in
scars.
some ultra-faint dwarf galaxies show strong R-process enhancement from a single rare event, likely a neutron star merger or a rare magnetorotational supernova. Their chemistry teaches that even tiny galaxies can inherit a heavy gift from a singular explosion, and that this gift distributes unevenly. For the first epoch when neutron star binaries might require time to merge the relative scarcity of our process, in the lowest metallicity, stars aligns with delay time arguments.
Edges fade,
Yet rare
like
core
memory.
collapse channels could have contributed earlier. The script keeps both options penciled. He gives the first black holes a quiet paragraph because seeds matter. If some population 3 stars exceed a few tens of suns, direct collapse after core exhaustion can leave black holes that in dense environments accrete gas and become mini-quasars. Their X-rays travel, far warming the
Starlight
intergalactic
bends around
medium
it,
in the 21
and a ring of
centimeter
photons
story,
sketches
and
the
providing
nearest
an
thing to a
early
face
hard
darkness
background.
can have.
Whether the most massive halos permit direct collapse black holes without a star at all via strong Lyman-Werner fields that suppress
The
H2
halo
and
looks
prevent
solid,
fragmentation,
yet it's made of
remains
scattered
under
stars
test.
pretending
Either
to be
way, the
continuous.
seeds and the X-rays they emit are part of the same early weather that flips the hydrogen line from absorption to emission and sets the scale for the rapid appearance of luminous quasars by redshift 7. A quiet, lesser-known detail sits in nebular geometry. Even if a young cluster hosts
Each
very
cluster
hot
is an
stars
ancient
capable
colony.
of doubly
Its
ionizing
stars older
helium,
than the continents that now hold the
He2
observer.
1640 signature can vanish when density-bounded regions vent ionizing photons, or when clumpy gas breaks the simple conversion between ionizing hardness and emergent line strength. Non-detections therefore limit either the stars or the enclosure. The constraint reads as much about the room as about the lamp. He keeps uncertainty present without heat. Direct detection of population 3 stars remains absent because their lives are too short, and their light too faint and redshifted once diluted by time. Candidate lines appear and fade under deeper scrutiny.
The event horizon
Chemical
draws
tagging in
no
halo
line.
stars depends on
Yet
models of
everything around it
three-dimensional non-local
rebels in
thermodynamic
silence.
equilibrium atmospheres, whose corrections can shift abundance ratios by tenths of a dex. Dust yields from first supernova depend on destruction in reverse shocks. The critical metallicity may vary with density and radiation environment. Each caveat narrows a corridor but leaves the hallway open. 3 fresh ironies take their places. The first lights are best studied by the shadows they cast in later chemistry, so brightness begets darkness as evidence.
The jet
The
shines
most
for
primitive
thousands of
stars by
light
composition
years. A cosmic
require the most
filament
careful
drawn
modern
by
modelling to
unseen
interpret.
hands.
So
Within it,
simplicity forces
knots of
sophistication,
brightness pulse
and the
drift,
oldest surviving witnesses
each a
are not the
record of
first
past
actors but the
beatings at the
second
core.
generation born from their
HST-1,
ashes,
a
so
luminous
memory
knot,
belongs to
once outshone
descendants
the
rather
nucleus.
than to
Proof
pioneers.
that even Gravity's edge
He lets a
flickers with
gentle
memory.
analogy keep the temperature even a high dry plateau, after first snow receives no footprints until the first animals cross. The snow is pure, the cold intense, and tracks from the earliest pass melt fastest in sunlight, leaving only subtle
Their arcs
compressions that
linger
later
like
snows
fingerprints
preserve.
on the glass of
One
time.
returns much later and reads small differences in firmness beneath the crust to infer the
The
path.
black hole's power is
Population
paradoxical.
3 are the
Its spectacle
animals,
comes from
the
what it
first
refuses to show.
low-mass stars, the preserved compressions and our spectra, the probing feet that find the firm patches. Certainty is replaced by likelihood, but the root still emerges under careful pressure. He closes the room with the ledger. The roll requires one accepted fact. The first stars formed from metal-free gas, are typically massive and short-lived, and seed the universe with the first heavy elements, and in some channels, black hole seeds that warm and ionize their surroundings. One poetic lesser-known detail of a 1640 line, a narrow hard beacon of very hot metal-free photospheres,
Even
remains a
distant
sought-after signature, whose limits say as much
feel
about
the
gas
echo.
escape as about starlight. One quiet scientific mystery, the initial mass function of population 3 and the frequency of pair instability versus faint core collapse deaths, along with whether any low-mass, truly pristine survivors still orbit in our halo. 3 soft ironies. The most transient lights write the most durable chemical page. The poorest gas produces the richest diagnostics, and the brightest ancestors are read through the dimmest descendants. Only took a molecule that
Where
cools poorly to make giants
was
that
born
live briefly.
from
Only took a
chaos.
pinch of carbon and dust to start. The longlifers only took a handful of ultra-metal-poor spectra to reconstruct a population no telescope will ever see directly. He leaves the forgotten populations as they are absent in image, present in imprint, and lets the first metals drift outward, thin as breath, toward the wider mechanisms that sculpt structure with gravity's long patience. He lets gravity take the whole stage and speak in its slowest voice, because structure does not appear, it accumulates.
The halo
An accepted fact
that
steadies the
never
floor
ends.
in a universe seeded by small, nearly scale-invariant
Heat that never
fluctuations.
speaks.
Cold,
Invisible
dark matter
X-rays carry the
collapses first
conversation
into
between the
tiny
galaxy
halos that
and the
merge and
cluster.
accrete to build larger ones, while gas cools inside those wells to make the visible parts stars and disks and bulges. The cosmic web filament sheets and knots emerges from this hierarchy as a natural pattern of flow, and the statistics of that pattern match the faint ripples inscribed on the oldest light. He listens to how patience acquires edges. Within halos, density profiles relax toward a
Contours of
common
an
form,
ancient memory.
steep outside, shallower inside, while in falling material
The border
turns
that
around at a
refused to
radius that
exist.
moves with time.
Where Messier 87 ends and
Splashback
the Virgo
radii
cluster
marked by
begins,
acoustic
the
in
eye
particle
cannot truly
orbits
tell.
give halos a boundary written by dynamics
Chemistry
rather
of
than by
distance.
convention. Subhalos carry their own memories inward, stripped by tides
Through
yet
the
still
embroidery of
recognizable.
collisions, faint
Concentrations
tidal
map
shells
formation
became the
times
galaxy's
earlier,
delicate
halos
scars.
denser, later ones looser, with scatter that becomes its own signal. A lesser-known detail sits where the web touches each galaxy. Cold, narrow streams of intergalactic gas penetrate massive halos at early times and feed star formation directly, their temperatures set by geometry and shock placement rather than by virial expectations. In simulations and in indirect observations, these filaments deliver fuel faster than hot quasi-static atmospheres, would explaining why galaxies at
Its
redshift 2 to
edges
3
fade
sustain
like
high
memory.
inflow and high output at once. Gravity here is not only a well, it is a river system with tributaries that keep pace with the weather of feedback. He keeps a quiet scientific mystery near the bright end because a few early lights ask for more haste than models, once allotted massive galaxies, and billion solar mass black holes appear within the first 700 million years. And while revision in
Starlight
stellar
bends
masses
around it,
duty cycles
and a
and
ring of
line
photons
contributions
sketches
softens the
nearest
headline,
thing
the
to a
basic
face
requirement
darkness can
remains.
have.
Seeds must form early and grow efficiently, either by Eddington paste accretion that rarely stalls, or by starting
The
heavier
halo looks
direct
solid,
collapse black
yet
holes
it's
in
made of
special
scattered
halos
stars
where
pretending
molecular
to be
cooling is
continuous.
suppressed and inflow remains smooth. Neither path is forbidden, both are demanding. The ledger keeps them penciled rather than inked. 3 soft ironies roll past like wheels on gravel. First, the structures that look most sudden, luminous
Each
quasars,
cluster is an
compact
ancient
starbursts,
colony.
are
Its
the
stars
product of
older
the
than
longest
continents
preparation,
that now hold the
billions of
observer.
orbits, and a century of millions of years of quiet infall deliver the moment that appears overnight. Second gravity, an attractive force with no built-in scale for stopping, produces objects whose growth is limited, mostly by how feedback from starlight and black holes throttles the very inflow gravity invites, a pull moderated by its own consequences. Third, the most informative boundaries of halos. The splashback edges are defined by particles that overshoot and return, so a system's limit is drawn by motion that crosses it. He lets the web be seen in
The event
kinematics and in maps
horizon
at
draws
once.
no line.
Redshift space
Yet
distortions
everything
flatten
around
clusters
it
along the line of
obeys
sight,
its silence.
or stretch them depending on scale, turning peculiar velocities into a ruler for growth. Weak gravitational lensing turns the shapes of background galaxies into contours of foreground mass sketching filaments that starlight does not. The two together measure how stubbornly gravity turns small ripples into structure, a check on whether the expansion's late acceleration has trimmed the web's vigour. The numbers lean slightly toward a quieter web than the simplest early
The
fits
jet
predict.
shines for
With
thousands of light
impatience and
years,
error bars,
a
a
cosmic
whisper noted
filament
earlier and
drawn
left
by
unshouted
unseen
here.
hands.
He walks inside
Within
galaxies
it,
without
knots
haste
of
because the
brightness
conversation
pulse
between
and
halo
drift,
and disk is long.
Each a record of
Angular
past
momentum
feedings
is
at the
acquired
core.
by torques from the
HST-1,
tidal field
a
and
luminous
then
knot, once
redistributed by
outshone the
bars,
nucleus.
spirals and
Proof
mergers.
that even gravity's
Disks
edge
thicken,
flickers with memory.
the stars scatter off giant molecular clouds and resonances. Bulges grow by violent coalescence or by slow buckling from within, and outflows sculpt the inner dark matter, sometimes easing cusps into
Their
cores where
arcs
feedback
linger
couples
like
strongly.
fingerprints on the glass of
Dwarf
time.
galaxies betray this coupling. Most clearly,
The
repetitive
black
bursts
hole's
of star
power is
formation
paradoxical.
inject energy
Its
into shallow
spectacle comes from what
potentials,
it refuses to
breathing
show.
the gas in and out and softening central densities. The same process that lights small galaxies also reshapes the wells beneath them. A lesser-known note holds on the outskirts of groups the backsplash population galaxies that once dove into a larger halo and now orbit just beyond its nominal edge, carry signatures of brief intense environmental processing despite their present freedom. Their gas fractions, star formation rates and orbits remember a visit. The web's geography folds history into position. He keeps uncertainty where humility belongs. Small-scale tensions, the excess of predicted subhalos,
Even
compared with
distant
luminous
galaxies
satellites' inner density slopes
feel the
that sometimes look shallower than cold dark matter's, naive cusps and central densities of the largest dwarfs that once seemed too big to host, the observed faint companions have softened under better baryonic physics and deeper censuses, yet they remain a classroom feedback reionization and selection bias explain much. Alternatives warmer or self-interacting dark matter explain differently. Both camps agree on large scales and spar at small ones. The mystery is not a crisis, but a menu of subtlety.
Born from chaos.
3 more ironies settle like coins under paper. Only took supernovae brief local events to rewrite the shape of dark matter, thousands of light years across, so noise sculpts bedrock. Only took satellites that are almost too faint to find to test the nature of an invisible particle, so the smallest lamps probe the darkest physics. Only took an outermost caustic in particle orbits to give halos their most physically motivated edge, so a boundary is fixed by crossing rather than by wall. He slows to the cadence of mergers, because growth gains most of its drama in quiet arithmetic. Major mergers alter morphologies, feed central black holes and fling stars into halos.
Between the galaxy
Minor
and the
mergers,
cluster.
more frequent thickened disks, build stellar envelopes, and add streams that wrap in phase space for giga-years. Dynamical friction drags massive companions inward, turning orbital energy into heat in the background of stars and dark matter. Over cosmic time, the mix shifts violent at early time secular. Later, so that by redshift 0, many spirals owe their bars and rings more to internal instabilities than to external strikes.
The border that refused to
Patience
exist.
replaces shock
Where
without
Messier
removing
87
consequence.
ends and the Virgo
He
cluster
lets the
begins,
calendar of
the
star
eye cannot
formation
truly
appear
tell.
like tide marks. The cosmic star formation rate density rises from the Dark Ages to a broad crest around redshift 2, then
Through the
falls by an
embroidery of
order of
collisions,
magnitude to the
faint
present.
tidal
A
shells
history
became the
shaped
galaxy's
by gas
delicate
supply,
scars.
halo growth, and feedback that grows more efficient as halos deepen. Galaxies at the crest burn quickly, fueled by streams and stirred by mergers. Later, hot halos around massive systems and outflows from earlier generations slow the cycle. Quenching
Its
spreads
edges
from high
fade
mass downward
memory.
environment and mass taking turns as leading causes. The universe builds fast and then edits. A quieter detail rests in orbit families. Within triaxial halos and barred disks, stars inhabit resonant boxes, tubes, and chaotic orbits. These families set how bars slow and how angular momentum trades. Places outer disks absorbing what inner bars shed, dark
Starlight
matter
bends
taking
around
its
it,
share.
and a ring of
The
photons
language is
sketches
dry,
the nearest
pattern
thing
speeds
to a
resonant
face darkness
radii,
can have.
but the effect is slow. Choreography form follows frequency. He keeps the early black holes in view because their growth times are a clock for the whole
The
script.
halo looks solid.
Seeds from
yet it's
massive
made of
population
scattered
3 stars,
pretending
tens
to
of
be
solar masses,
continuous.
require uninterrupted near Eddington accretion to reach 1 billion solar masses by redshift 7. Heavier seeds from direct collapse relax the demand but ask for rarer conditions. Super Eddington episodes in slim disks ease both routes. In every case,
Each
a supply
cluster is
chain
an
from the
ancient
web to the
colony,
nucleus
its
must stay
stars
open,
older than the
while
continents
feedback
that
does
now
not
hold
fence
the
it off.
observer.
X-rays from these engines warm the intergalactic medium and leave timing marks for the 21 centimeter story told earlier. Signs align, not proofs. He parks 3 fresh ironies at the edge of the web where voids widen. The emptiest region's voids grow fastest in commoving size because they evacuate while walls thicken, so absence expands more quickly than presence. The galaxies that sit in the densest knots sometimes stop forming stars earliest quenched by their own success, while ones in quieter lanes keep simmering crowding shortens life. And the same
The event
fluctuation
horizon
field that
draws
is almost
no line,
perfectly Gaussian at
yet
recombination
everything around
grows
it
into non-Gaussian
obeys its
architecture.
silence.
At late times, linearity builds non-linearity with no external tutor. Smooth seeds, ragged harvest. He offers a gentle analogy, one that keeps the room dim. Think of a slow delta where a river spills into a shallow sea. Silt builds fingers of land that branch and rejoin channels, capture and abandon, and small eddies spin off ponds that persist for years. Occasional floods reroute whole limbs, but most change is the work of water-pushing patient grains.
The jet shines
Islands
for
host
thousands
brief
of light
fires
years,
that clear brush and
cosmic
harden
filament
soil,
drawn
and
by
their ash
unseen
later
hands.
feeds wet meadows.
Within it,
Return
knots
after
of brightness
decades,
pulse
and the
and
delta
drift,
is larger,
each
more
a record
braided
of
and
past
calmer.
feedings at the
Gravity's
core.
long patience forms that
HST-1,
delta
a
in 3
luminous knot,
dimensions.
once outshone the
Galaxies
nucleus.
are its
Proof
islands.
that even gravity's
Fires
edge
their
flickers with
feedback
memory.
ash. The first metals and the sea beyond the web, the expanding background that sets the long shoreline. He lays down what the role requires in one unbroken breath, one accepted fact hierarchical assembly in a cold dark matter universe builds. The web populates halos and governs how gas flows into galaxies, where feedback modulates the
The
pace.
black hole's power
One
is
poetic
paradoxical.
lesser-known detail,
Its spectacle
splashback
comes
radii
from what
and
it
cold
refuses
streams,
to show.
give halos physical edges and arteries boundaries and supply routes, written by orbits rather than by definitions. One quiet scientific mystery, how the earliest massive black holes and compact galaxies grew so quickly without breaking clocks set by other data, and whether small-scale tensions demand only sharper baryonic physics or a modest adjustment to dark matter properties. 3 soft ironies: the fastest changing lights are results of the slowest accumulation. The shape of invisible matter can be sculpted by brief bursts from visible stars, and the most telling edges of vast diffuse systems are drawn by particles that are temporally furthest beyond them. Only took orbits that crossed to write a boundary. Only took feedback's breath to move dark stone. Only took a handful of early overachievers to check a century of theory without overturning it. He lets gravity continue the same patient sentence filament to halo to galaxy. Galaxy to wind no hurry, no noise, just a web tightening where matter gathers and loosening where it does not. Time-writing structure as if it had nowhere else to be. He
Where
lowers the flame until
smoothness
temperature
was born
itself
from
becomes the
chaos.
story, and an accepted fact steadies the surface. The cosmic background cools with the scale factor so that its temperature follows TZ. T0112. A simple law born of adiabatic expansion that carries the photon bath from thousands of Kelvin at the first atoms to 2.725 K now. Gas not tied to radiation cools 2 first by expansion, and Compton scattering with the background, and later by its own radiative lines, while young galaxies interrupt the curve with heat from stars, black holes and shocks. The universe is a sea that
Heat
cools,
that never
then learns
speaks.
to stir.
Invisible
keeps the
X-rays
thermometer
carry the
quiet and
conversation
precise.
between the galaxy
The most
and the
exact
cluster.
measurement of the present background temperature comes from a spaceborne spectrometer that found an almost perfect black body. A spectrum whose deviation from plan fits inside instrumental errors. Against that anchor, the 1A+ relation receives direct checks at earlier times. Molecules in distant clouds, rotational and fine structure levels in COCN and C. I sit in equilibrium with the ambient radiation, and their relative populations
The
read in
border that
quasar
refused to
absorption
exist,
systems
where
imply a
Messier 87
background
ends and the
temperature
Virgo
that
cluster
scales
begins,
just as
the
the
eye
simple
cannot
rule
truly
predicts. A lesser-known detail glows here before the satellite result. A cold molecule in the Milky Way CN already hinted at a
Through
few
the
degrees
embroidery
above
of collisions,
absolute zero
faint
by the
tidal
tiny
shells became the
overpopulation of its
galaxy's
lowest
delicate
excited
scars.
state. A terrestrial laboratory stuck in the sky. Later the same trick moved to high redshift with CO absorption, where the level ladder becomes a thermometer that looks like punctuation on a line. He watches the curve pick up faint embroidery where heat sneaks in. When the first ionizing sources ignite their photons, raise the temperature of intergalactic hydrogen to tens of thousands of Kelvin, and fix an equation of state for the diffuse gas hotter in underdense regions at first, then cooling through expansion,
Its
and
edges
Compton
fade
scattering until
like memory.
photoheating and adiabatic losses trade blows. Later, helium's second ionization adds a second smaller warm-up, often attributed to hard photons from quasars. The thermal history of the intergalactic medium becomes a memory of light sources more than of expansion, measured indirectly in the widths of Lyman A forest lines, where thermal motions and small-scale
Starlight
bulk
bends
flows
around it,
blend into
and a
Doppler
ring of
parameters.
photons sketches the
Against
nearest
those
thing to a
widths,
face
models of
darkness can
structure
have.
and radiation backgrounds infer a temperature-density relation that rises with reionization peaks and then declines. The sea
halo
cools,
looks
is
solid,
stirred warm and
yet
cools
it's made
again.
of scattered
A quiet
stars
scientific
pretending
mystery
to be
rests on the surface of that
continuous.
sea, because deviations from the perfect 1+'s cooling for photons would betray energy injection, extra heating, or cooling at early times. Such episodes would not only change the relation, but distort the black body spectrum into M-type from early high redshift
Each
injection,
cluster is an
where
ancient colony.
Comptonization
Its
is
stars
efficient,
older
or
than the
Y-type
continents
from
that
later
now
low
hold the
redshift
observer.
heating, where comptonization is partial spectral shapes. Limits so far are tight the background is almost too perfect, and yet proposed future spectrometers aim to push sensitivity orders of magnitude deeper, chasing signatures of decaying or annihilating particles, evaporating primordial black holes, or the integrated faint imprint of reionization and structure formation. The quiet question is not whether small departures exist. Gravity alone ensures some, but whether any depart loudly enough to hear above perfection.
The event
Three
horizon
soft ironies
draws no
settle
line,
like frost on
yet
glass.
everything around
First,
it
the most massive
obels
heat
in
reservoir in the
silence.
universe is proved by the absence of features perfection. In the spectrum serves as evidence of the hottest, earliest violence. Silence reports fire. Second, the very act of galaxies growing star formation, and black hole accretion reheats parts of a universe that would otherwise keep cooling. So aging introduces local warmth. Time makes pockets feverish even as the bath chills. Third, the thermometer for the background
The
at
jet
earlier times
shines
comes
for
from the
thousands
tiniest
of light
clocks in the
years,
coldest
a
clouds.
cosmic filament
So distant
drawn by
cosmology leans
unseen
on the spin and
hands.
rotation of a small
Within it,
handful of
knots
molecules.
of brightness pulse
Immensity
and drift,
asks molecules for
each a
time.
record of past
He lets the
feedings
Lyman
at the
forest
core.
speak in widths and shapes
HST-1,
instead of
a
in
luminous
images.
knot, once
Absorption
outshone the
lines
nucleus,
toward
proof
bright
that even
quasars
gravity's
tessellate
edge
the
flickers with
one-dimensional
memory.
density field along each sight line, and their thermal broadening and pressure smoothing encode temperatures across redshifts 2 to 5. Hydrodynamic simulations translate these distributions into thermal histories, revealing reheating near the end of reionization and cooling thereafter. When a second reheating appears in the data, it marks helium's turn.
The black
The
hole's
scatter
power
across
is
voids
paradoxical.
and filaments
Its
says how
spectacle
patchy
comes
that
from what it
heating is.
refuses to show.
Overlaid on this is a lesser-known calibration, the curvature statistic, a measure of how quickly flux changes with wavelength acts as a temperature proxy less sensitive to noise than individual line fits. Temperature becomes a function of roughness rather than of single widths. He returns to the cosmic bath to hold the idea of spectral distortion without warming it. Inverse Compton scattering of CMB photons by hot electrons in galaxy clusters. The thermal Sunyaev-Zeldovich TSZ effect produces a Y-type signature that summed over all clusters and groups yields a mean Y distortion for the sky. The predicted average remains beneath current all-sky detectors' limits, yet narrow-band multi-frequency maps have already measured TSZ for individual clusters, and even statistically for low-mass halos. Free emission bremsstrahlung from ionized gas adds a low-frequency tail to the distortion budget. Kinetic SZ from moving electrons adds small-scale anisotropy rather than spectral change. a future absolute spectrometer could integrate all these heating events into one number and one curve,
Where smoothness
converting the thermal
was
history
born
of structure
from chaos.
into a small deviation from perfection. It is an accounting of every warm electron between recombination and now, and written as a tiny bend in a straight line. He threads in the gas that never quite joins galaxies because its temperature is the ledger's midline. After ionization, most baryons live not in stars but in a tenuous, warm, hot, intergalactic medium at 105-107 K. Its faint X-ray lines and far ultraviolet absorptions reveal densities and temperatures that close the baryon census. This diffuse reservoir participates in heating the background only
Heat
by
that never
scattering and by
speaks.
free emission,
Invisible
too faint to
X-rays
isolate,
carry the
yet
conversation
it sets
between
the
the galaxy
baselines for
and the
feedback
cluster.
and accretion. Measure its temperature, and one fixes how much of the universe remains in a simmer versus in a chill. The sea's middle depth decides how quickly islands of light can grow. He lets 3 more ironies pass without raising the voice. Only took the narrowest quasar absorption lines to measure the temperature of space between galaxies, while all of the galaxies themselves contributed more confusion than clarity. Only took energy injected by the
border that
smallest
refused to
actors run-of-the-mill
Where
supernovae
Messier
and
87
steady
ends and the Virgo
cluster
low-luminosity black
begins,
holes
the eye
integrated
cannot
over
truly
time
tell.
to set the mean Y distortion
chemistry
budget
of
that, if
distance.
ever measured, will stand beside outbursts in clusters. The ordinary outweighs
Through the
the
embroidery of
spectacular.
collisions, faint
Only took the
tidal
discovery
shells
that
became the
helium
galaxy's
second
delicate
ionization
scars.
occurs late to reveal that quasar light. Not stellar light sets the final warming we learn, who lights the kettle by watching the steam, not the flame. He steps to the cooler foreground to recall how the photon bath and gas spoke directly when the universe was young. Before the first stars, Compton scattering couples electron temperature tightly to the background, enforcing T-gas, T-CMB, until decoupling proceeds and the gas drops below. Thereafter, the gas temperature falls as 1 plus is
Its
2
edges
until starlight
fade
and X-rays
like
reverse the
memory.
trend. The balance between adiabatic cooling, Compton cooling heating and photoheating writes a curve that later habituates into the forest statistics. The earlier claim of a deep absorption trough in a global 21 centimeter profile, if it were to hold, would ask the gas to be colder than adiabatically expected, or the background brighter than standard.
Starlight
A
bends
choice
around
between
it,
extra
and a
cooling
ring of
perhaps from
photons
dark
sketches
matter
the
baryon
nearest thing to a
interactions,
face
or extra
darkness can
radio
have.
backgrounds perhaps from earlier creters. Subsequent experiments with improved systematics pull the amplitude toward caution.
The halo
mystery
looks
stays
solid,
low,
yet
not
it's made
erased.
of scattered
A lesser-known
stars
detail
pretending
turns
to
up
be
where the background meets
continuous.
instruments. Even a perfect blackbody acquires slight distortions from scattering in our own galaxy's ionized gas, tiny direction-dependent Y-like imprints that absolute spectrometers must subtract. Plasma around Earth and in the solar wind
Each
leaves
cluster
still
is an
fainter
ancient colony.
signatures.
Its stars
The
older
universe
than the
cools
continents that now
cleanly,
hold the observer.
instruments live in a warm neighborhood, and calibration inherits the weather. He keeps uncertainty as breath rather than as wind. Lyman thermal inferences depend on assumptions about the ultraviolet background's hardness and variation, and on the mapping from flux to density that simulations provide. Molecular excitation thermometers need shielding corrections, collisional rates and dust fields that are not always known. Predicted spectral distortions from structure formation overlap with those from reionization, and with any exotic early heating and separating
The
them
event
will require
horizon
both
draws
absolute
no line,
spectra and
yet everything
anisotropy
around
maps.
it obels
Yet the
its
overall
silence.
curve remains calm. Photons cool as 1 Pallas gas cools until light arrives, and later the sea adjusts around islands of heat. He adds a gentle modern analogy to make the curve legible without stirring it. Imagine a broad lake that freezes in autumn. As the air chills, the water near the surface cools more quickly than the depths, and then the whole face takes ice. Later, campfires along the shore, and a rising moon soften patches, sending warm ripples under the crust.
The jet shines
By
for
late season, the
thousands of
lake
light
is colder
years,
than when it
a
first
cosmic
skimmed over,
filament
yet
drawn
streaked
by
with irregular
unseen
warmth
hands.
that remembers
Within
where
it,
fires were brightest.
knots of
A
brightness pulse
thermometer
and
dipped
drift,
through holes at
each
different
a record
distances
of
from the
past
shore,
feedings at the
records
core.
a smooth fall with
HST-1,
rare
a luminous
upturns.
knot,
The
once
cosmic
outshone the
sea is that
nucleus,
lake
proof
expansion
that
is
even
winter
gravity's edge
ionization.
flickers with memory.
The first fires, quasars, the late sparks along the far bank and spectral distortions, the delicate ripples that tell where warmth travelled. The black body holds the ice thickens and the fires leave traces rather than cracks. He closes the
Their
page with
arcs
the ledger the
linger
roll
like
requires in one
fingerprints on
breath,
glass
one
of
accepted
time.
fact, the background temperature scales as 1 pluses. In an expanding universe,
The black hole's
while the
power is
intergalactic
paradoxical.
medium's thermal
Its
history
spectacle
rises
comes
with
from what it
reionization
refuses to show.
and falls thereafter, its temperatures measurable in the Limana forest. One poetic, lesser-known detail excitation of Joe and CN in cold, distant clouds acts as a radiation thermometer that confirms the background's cooling, not by looking at the sky's glow, but by reading the posture of a few molecules. One quiet scientific mystery, the amplitude and shape of any spectral distortions M and Y that would reveal energy injection from structure quasars or new physics beyond the near-perfect blackbody, whether any deviation rises above silence. 3 soft ironies. The surest proof of ancient heat is a spectrum too smooth to show it. The universe cools while its parts learn to make heat, and the temperature of the biggest room is taken with the smallest tools. Only took the width of a forest line to read the warmth between galaxies, only took the absence of a wiggle to constrain a billion degrees of history, only took molecules turning gently in the dark to confirm a law of cooling written across all of space. He lets the sea resume its slow chill, and leaves the small fires flickering where they belong, faint ripples on a surface that keeps its shape. He
Where
listens for what does not
smoothness was
shine,
born
and hears the
from chaos.
longest memory in the room because dark matter keeps a ledger that stars quickly smudge. An accepted fact steadies the hand in the standard picture. Most mass in galaxies and clusters is a cold, collisionless component that interacts primarily through gravity, collapsing first and deepest setting potentials into which gas later falls. Its halos grow hierarchically, their inner regions assembled early, and their outskirts written by later infall, so each radius remembers a different season of the universe. He slows the view until phase space comes into focus, a sheet of positions and velocities that folds without tearing. As small
Heat that
fluctuations
never speaks.
collapse, the sheet wraps into
Invisible
spirals
X-rays carry the
intersecting itself in
conversation
position,
between the
but
galaxy
never in the
and the
full
cluster.
6-dimensional map. When coarse-grained, averaged over the fine filigree, the pseudo-phase space density, a simple ratio of mass density to velocity dispersion cubed, falls with radius in a near power law, a quiet regularity that shows up from dwarfs to clusters. It is as if halos forget many details yet preserve a slope. A lesser-known detail rests within that abstraction, actions integrals of motion, that label orbits change only slowly if the
border that
potential
refused
grows
to exist.
adiabatically.
Where
So the
Messier
distribution
87
of
ends
orbital
and the Virgo
actions in a
cluster
halo
begins, the
becomes
eye
a
cannot
fossil
truly
of the
tell.
assembly rate. Where growth pauses, actions cluster. Where growth surges, they spread. In practice,
Through
this
the
means
embroidery
streamed
of
shells in
like
kinematic
faint
ridges in
tidal
stars
shells
and
became
even
the
in dark
galaxy's
matter
delicate
substructure
stars.
carry timing stamps that survive long after luminous traces have scattered. The memory lives in the invariants, not in the headlines. He keeps a quiet scientific mystery alongside this order, because the particle itself remains unintroduced. Is the dark matter perfectly cold and collisionless, a very weakly interacting relic, or does it
Starlight
scatter
bends
gently
around
with
it,
itself,
and a ring
softening
of photons
cores and
sketches the
rounding
nearest
traxial
thing to a
shapes?
face
Is it
darkness can
slightly
have.
warm, erasing small halos? Does it ever talk to baryons beyond gravity in the early universe? Each option leaves fingerprints at
The
small
halo
scales.
looks solid,
Central
yet it's
density
made of
slopes
scattered
in,
stars
dwarfs
pretending to
the
be
abundance and
continuous.
masses of satellites. The survival rate of sub-halos that pucker stellar streams the thickness of strong lens arcs, where invisible clumps cause small kinks. The large picture agrees across choices, while the small picture writes a careful, multiple choice.
Each
The
cluster
sky
is an ancient
answers
colony.
slowly.
Its stars older than the
Three soft
continents that now
ironies
hold the
line up
observer.
like small stones at the edge of a river. First, the matter that does not collide or glow remembers more than the matter that collides and radiates. Inelasticity erases while near-perfect elasticity preserves. Second, the brightest traces starbursts and active nuclei most efficiently blur the very signatures we seek in dark matter by heating gas stirring stars and flattening cusps. So learning about the dark requires neighbourhoods where light behaves politely. Third, the best clocks for the earliest assembly. Faint, cold stellar streams in
The event
galactic
horizon
halos are drawn
draws
by the
no
least
line,
luminous populations.
Yet everything around
So the
it
dimmest chalk
obeys
marks
its
date
silence.
the oldest events. He lets halos show their edges because boundaries carry time. Beyond virial radii drawn by convention lies the splashback caustic, a sharp drop in density where orbits turn for the first time. It moves outward as fresh material falls in and becomes shallower where accretion slows. Measure its radius in stacked galaxy clusters, and one reads a recent mass growth rate. Map it around single galaxies, and one draws the last few
The jet
gigayears as a
shines
ring.
for thousands of light
Dark
years.
matter, by crossing its
cosmic
own edge,
filament
writes where the
drawn by
present
unseen
begins.
hands.
He follows
Within
substructure
it,
without hurry.
knots of brightness
Halos hold
pulse and drift,
subhalos that host
each
satellites
a
or
record
remain
of
dark.
past feedings at
They
the
sink
core.
under dynamical
HST-1,
friction or are
a
ablated by
luminous knot,
tides,
once
and
outshone the
sometimes survive
nucleus,
to jab
proof
fine
that
traces
even
cold
gravity's edge
streams
flickers with
from
memory.
disrupted globular clusters, leaving gaps and wiggles along those ribbons. With enough stream length and enough patience, these disturbances map a spectrum of the subhalo masses down to scales too small to light a single star,
Their arcs
where gaps
linger
are
like
too few
fingerprints
or
on
too
glass
soft.
of time.
Either the subhalos are rare, their masses smaller than expected, or the
The black
string
hole's
model's
power
too
is
stiff.
paradoxical.
Each
Its spectacle
interpretation
comes from what
returns
it
to the
refuses
particle.
to show.
Colder matter breeds more small lumps. Warmer matter smooths them away. Self-interactions round and soften. A lesser-known detail hums at the cluster scale. Strong gravitational lenses produce multiple images of background galaxies whose arcs should be smooth. In reality, small kinks and flux anomalies betray dark subhalos too dim to see. By fitting these perturbations across many lenses, astronomers build a census of substructure that ignores starlight entirely. The halos of halos become visible through distortions in something else's image. One sheet of glass shows bubbles by how it warps the reflection of a window beyond. He keeps uncertainties where they remain most honest in the centre. Baryonic feedback, rapid gas outflows from supernovae or accretion episodes can puff stars and dark matter alike, turning steep inner density cusps into shallow cores in dwarf galaxies and thickening the disks that host them. Reionization empties the smallest halos before they can make stars, leaving many satellites dark. Selection biases hide diffuse systems. When these effects are modelled with sufficient resolution and patience,
Where
many
smoothness
small-scale
was born
crises soften
from
into
chaos.
puzzles. Yet a corridor stays open for dark matter that is cooler than warm but warmer than cold, or for gently self-interacting matter whose scattering lengths change with velocity. The mystery does not demand a rewrite, it requests a footnote with finer print. 3 more ironies pass by with hardly a wake, only took stellar explosions that run out of fuel in seconds to reorganize kiloparsecs of invisible matter. Over hundreds of millions of years, flicker moves stone. Only
The
took
halo
satellites whose total
that
light
never
is less than a
ends.
single bright globular cluster to weigh particles
Heat that
that
never
permeate
speaks.
clusters
Invisible
test
X-rays carry the
oceans.
conversation
Only
between the
took measuring
galaxy
the location
and
of
the
a
cluster.
halo's first apocenter to decide how quickly it has grown. Periphery fixes recent history. He returns to the local group where scale becomes intimate. The Milky Way's halo holds dozens of faint satellite streams that lace the sky and a total mass near the low trillions of suns. Andromeda's counterpart mass and its retinue of dwarfs echo these numbers, the radius where their combined gravity arrests the Hubble flow. The turnaround surface marks the boundary
border
of the
that
group's
refused to
patience.
exist. Where
Peculiar
Messier 87
velocities of
ends
nearby
and the Virgo cluster
galaxies draw
begins,
this shell
the
like
eye
a
cannot
pencil
truly
line
tell.
on transparent paper. It is a timekeeper too. The deeper the well, the nearer the shell for a fixed expansion. He notes a lesser-known tool
Through
that
the
reads
embroidery
halos
of
like
collisions,
tree rings,
faint
age
tidal
gradients
shells
in
became
stellar
the
halos,
galaxy's delicate
metallicity and
scars.
kinematics as a function of radius, reflect the mix of accreted dwarfs and in situ stars formed from gas pulled outward in early feedback. Outer envelopes dominated by ancient metal pore debris tell of early dry assembly. More mixed populations point to prolonged minor merging. Although this is a luminous diagnostic, it cross-checks the darker halo that assembled early should be more concentrated and host an older outer light. The starlight does not measure the matter directly.
Its edges
It echoes
fade
its schedule.
like
He
memory.
listens for action space fossils because invariants stay legible. Moving groups in the solar neighborhood, resonant ridges and curled phase space spirals in vertical motion reveal past nudges from satellites and from the bar. At larger radii, cold streams align along great circles until precession in a triaxial potential tilts them. These patterns allow reconstructions of the halo's shape
Starlight
rounder or
bends around
flatter,
it, and a ring of
aligned or
photons
twisted,
sketches
and
the
of any
nearest
time
thing to a
variation.
face darkness can have.
If dark matter self-interacts, inner shapes trend round. If it does not, traxiality persists unless baryons
The
dominate the
halo
core.
looks solid,
The measurement
yet it's
is
made of
smoothed by
scattered
time, yet
stars
sensitive to
pretending
force
to be
law.
continuous.
Geometry becomes memory. He places a gentle modern analogy where it keeps the proportions calm. Think of a glacier that flows slowly down a valley. Snowfalls arrive in seasons, debris falls from the walls, and the ice carries layers forward, folding and shearing them around embedded rocks.
Each cluster is an ancient
Decades
colony.
later,
Its
bands of
stars
darker
older
ice
than the
and subtle
continents that
moraines
now
at the
hold the
edges reveal
observer.
both supply and speed. Measure the spacing of bands and one reads winters. Measure the arc of moraines and one reads summer melts. Dark matter halos are those glaciers flowing without melting. Folding a phase space sheet into quiet spirals, carrying forward a complete but compressed archive of assembly. The stars are pebbles caught and lifted, sometimes melted and refrozen by bursts of warmth. The scarp at the side is the splashback. The valley beyond is the expanding universe. He does not hurry the particle, but he leaves a margin for how it might appear.
The event horizon
Detection
draws
experiments
no line,
underground in
yet
space
everything
and at
around
colliders
it
continue to
obeys
test
in
candidates.
silence.
Indirect searches look for annihilation or decay in G-rays and charged particles from dwarfs and the galactic center. So far, silence. The constraints bite into parameter space, but gravity's report remains sufficient to hold the shape. Halos exist, substructure abounds, and the web fits. Three final ironies keep the voice low. The invisible writes the clearer structure, while the visible edits and blurs. The thing that scarcely collides leaves the
jet
sharpest
shines
caustic,
for thousands
while
of light
collisional
years,
gas
a
turns
cosmic
edges
filament
soft.
drawn
And the
by
best
unseen
arguments for a
hands.
non-baryonic
Within
component
it,
come from places
knots
where
of
baryons are
brightness
few
pulse
outer
and drift,
halos and faint
each
dwarfs,
a
so
record of
absence
past
warrants
feedings
presence.
at the core.
One accepted fact rests at the
HST-1,
center.
a luminous knot,
The bulk of
once
mass in
outshone the
galaxies and
nucleus,
clusters
proof
lives
that
in
even
dark
gravity's
halos
edge
that
flickers
assemble
from memory.
hierarchically, hold substructure, and preserve their growth in orbital invariants and edges. One poetic, lesser-known detail, that the distribution of actions and the near-power law of pseudo-phase space density together act as an unassuming fossil record, turns an algebraic slope into a museum label. one quiet scientific mystery
The black
remains the
hole's power
particle's
is
identity,
paradoxical.
and
Its
whether
spectacle
subtle
comes from what it
self-interactions
refuses
or
to show.
finite warmth shape cores, subhalos, and streams enough to leave a signature above baryonic weather. Three soft ironies close the page. The dimmer remembers, the brighter forgets. The weaker interaction preserves, the stronger erases. The outskirts decide the present. Only took streams thin as threads to test lumps. The size of forgotten galaxies only took a ring at the first turnaround to date. Growth only took invariants that barely changed to narrate a history that never stops. He leaves the matter that does not forget to its slow, record-keeping patient and exact, while the story turns still even to cosmologies that imagine longer arcs than a single expansion, careful cycles drawn so faintly they barely disturb the ink. He opens a quiet door where cosmology sketches longer arcs than one expansion, and an accepted fact steadies the threshold, the standard model of a hot Big Bang with cold dark matter and a cosmological constant explains almost all large-scale observations with a single beginning and no earlier chapter required, yet mathematically consistent alternatives allow earlier phases, contractions, bounces, or conformal
Where
handoffs
smoothness
in which a
was
prior
born
universe
from
leaves
chaos.
faint boundary conditions for this one. Observation has not crowned any such script, but physics does not forbid them in principle. He lets the possibilities enter one by one without raising their voices. In ekpyrotic and cyclic pictures, a slow, ultra-stiff contraction smooths and flattens space before a bounce, so that what inflation achieves by rapid expansion is achieved instead by damping anisotropies and wrinkles, decay because the equation of state is greater than unity. After the bounce, expansion resumes with initial conditions already tidy. In loop quantum cosmology, bounces
Heat
quantum
that never
geometry at
speaks.
Planck densities,
Invisible X-rays
replaces the
carry the
singularity with
conversation between
repulsive
the galaxy
curvature,
and the
turning a
cluster.
collapse into an expansion when density reaches a critical value. In conformal cyclic cosmology, the remote future of a prior aeon emptied of mass by black hole evaporation and stretched to near-perfect uniformity can be rescaled conformally so that it becomes the smooth Big Bang surface of the next. The mathematics connects distant ends by stripping units while preserving angle-turning infinity into a boundary
The border
that
that
looks like a
refused to
beginning.
exist.
A lesser-known
Where Messier
detail
87
hums in this
ends and the Virgo
vocabulary.
cluster
The
begins,
cosmic
the eye
no-hair
cannot
theorem
truly
proved
tell.
under certain energy conditions says that universes with a positive cosmological constant forget most of their initial wrinkles and approach
Through the
sister
embroidery of
expansion.
collisions,
So
faint
late-time
tidal
emptiness in
shells
a
became
dark
the galaxy's
energy-dominated
delicate
aeon
scars.
tends to become smooth. Conformal pictures lean on this serenity, imagining that temperature and mass lose meaning, while angles and light-like structure remain so that the geometry's shape survives into the next aeon even if rulers and clocks do not. Smoothness becomes inheritance. He keeps a quiet scientific mystery where all such arcs bend entropy and the arrow of time. Tolman's old problem that a cyclic universe must face ever-growing entropy returns in modern clothes.
Its edges
Bounces must
fade
dilute or
like
export
memory.
entropy, so that each new expansion begins in a low entropy state, compatible with the observed thermodynamic arrow. Ekpyrotic smoothing lowers anisotropies, but not necessarily entropy. Loop bounces rely on microscopic degrees of freedom whose bookkeeping is still being assembled. Conformal cycles argue that mass fades and black holes evaporate, erasing local clocks.
Starlight
But whether
bends
that
around
trick
it,
truly
and a
resets
ring
the
of
arrow
photons
remains
sketches
debated.
the nearest thing
The
to a
calm
face
statement
darkness
remains
can
that
have.
every repetition must justify forgetfulness. Three soft ironies rest like pebbles on the table. First models
halo
designed
looks
to avoid
solid,
a beginning
yet
often
it's made
require
of
extra
scattered
assumptions
stars
to forget the
pretending to
past.
be continuous.
Amnesia is added to save memory. Second proposals that aim to soften the singularity often sharpen predictions that are hardest to test. what is most merciful mathematically becomes most austere observationally. Third, the hypothesis that the cosmos repeats itself turns out to be
Each
less
cluster
about
is an
cycles we
ancient
could
colony.
watch
Its
and more
stars
about
older than the
boundaries we can
continents that
barely
now hold the
infer.
observer.
Repetition hides in the least repetitive data. He lets possible fingerprints remain as pencil marks rather than ink. Some cyclic or pre-Big Bang scenarios can imprint a blue-tilted spectrum of primordial gravitational waves, or a cutoff in scalar power on the larger scales, or non-Gaussian patterns that differ from the almost perfect Gaussianity of inflation. Conformal cycles have been claimed to leave circular hot-cold imprints, or small hot Hawking points, from evaporating supermassive black holes in the previous aeon. Surveys have
The event
searched for
horizon
such circles
draws
and
no
points,
line,
reporting hints
yet
and
everything
counter-hints.
around it
None have
obels
crossed
its
the careful
silence.
thresholds that turn intrigue into result. The sky remains polite, nearly scale invariant, nearly Gaussian, nearly sufficient. He adds a lesser-known technical hinge because the bounces depend on more than poetry. Anisotropies in a contracting universe usually grow like A6, and can dominate threatening chaos the BKL behaviour unless a stiff component with W1 damps them. The ekpyrotic mechanism provides that damping. Loop quantum cosmology bounces
jet
rely on
shines for
discretized
thousands
area
of
and
light
volume
years,
operators
a
that cap
cosmic
effective
filament
curvature.
drawn by unseen
Ghost-free
hands.
higher derivative
Within it,
theories attempt
knots of
non-singular
brightness
transitions
pulse
without
and drift,
instabilities.
each a
Each
record of
mechanism
past
is
feedings
precise
at the
where it
core.
must be and delicate where it
HST1,
meets
a
data
luminous knot, once
nucleosynthesis.
outshone the nucleus.
The microwave
Proof
background
that
and
even
structure
Gravity's
must
edge
emerge
flickers
intact
with
after the
memory.
handoff. 3 more ironies drift through the calculus. Only took replacing a singularity with a regular minimum of the scale factor to make time continue. Yet that continuation leaves almost no stronger observational duty
Their arcs
than the
linger
singularity
like
did.
fingerprints on the
Continuity
glass
proves
of
shyer
time.
than a break. Only took a theorem that universes with dark energy forget their perturbations
hole's
to allow a
power is
future to see the
paradoxical.
past.
Its
Yet
spectacle
our
comes
desire
from
to
what it
read the
refuses
seed
to
asks
show.
for perturbations that are not forgotten. Forgetfulness must remember just enough. Only took a conformal rescaling that preserves angles to imagine continuity, but the instruments we build prefer rulers, not protractors. Angles are generous distances opinionated. He steps back to the present because every longer arc must fit the room we already measured. The cosmic microwave background's acoustic peaks. The late-time acceleration light element abundances from the first minutes, and the nearly Gaussian statistics of primordial fluctuations constrain any prehistory it must deliver almost the same initial conditions.
Even
Inflation
distant
provides